Narada sir, wait a while.
Okay.
Yes, sir, you can start.
Okay. Very good morning to you all. Today, we are having two eminent speakers. First speaker for our first session is Professor Dr. Atul Kulkarni, Dean Industrial Relations from VIIT Pune. And our second session speaker is Professor Dr. Swaz Deshmukh from Government College of Engineering, Karad. So today we'll start with Dr. Atul Kulkarni. So I will share my screen with Dr. R.R. Nothar to give the introduction of Professor Atul Kulkarni.
Good morning to one and all. It's my privilege to introduce today's speaker for session 1, Dr. Atul Prabhakar Kulkarni. Sir has completed his bachelor's in mechanical engineering from North Maharashtra University, Jalgaon. His MTech in mechanical manufacturing engineering from Dr. Babasaheb Ambedkar Technological University, Loneri, and also his PhD in mechanical engineering from Dr. Babasaheb Ambedkar Technological University. He has also completed his diploma in ISO 9000 and TQM. Presently, Sir is working in capacity of Dean Industry Institute Interaction at Vishwakarma Institute of Information Technology, Pune. Dr. Atul Kulkarni is member Board of Studies Mechanical Engineering at Savitribai Phule Pune University, Pune. Sir has total teaching experience of 20 years in Savitribai Phule Pune University. He has an industrial experience of 6 years as senior design engineer. His key research areas are VD coating for cutting tool applications, characterization of tool coating, cutting temperature analysis in machining, FEA for machining applications. Machining of exotic materials, composite materials, characterization of machining of PEEK and PT FE material, analysis of manufacturing process of historical objects. Sir has also published 43 research papers in reputed national and international journals. With this, I welcome Dr. Atul Kulkarni for session 1 and hand over the screen to Kulkarni sir. Kulkarni sir.
Yes, thank you, Professor Nothar, for kind and excellent introduction. At the beginning, I must say thanks to Dr. Kale, Dr. Narwade, Professor Ravindra Nothar for giving this opportunity to deliver a session on a 1-week faculty development program on product design and novelty. Before starting off my session, I hope all of you are safe and good at your place. Please take care of yourself, your own members. So, as Dr. Narode told me that I would like to take one session on this one for the student. Definitely, all of us are going in a very crucial condition, and it's very difficult to keep ourselves motivated. And a program like faculty development program, then interaction with the through webinars will definitely help us to keep motivated in such pandemic situation. So with this, I'm going to share my screen. Today, I'm going to talk on the mathematical approach, as the theme of the faculty development program is product design and novelty. So once something has been designed, if it is available in the form of some models or modeling concepts, then definitely a generalized terms can be developed. So during my presentation, I'm going to cover some basic approach for mathematical modeling and which leads to the product design. And at the end, I'll explain you some case studies, and I'll show you some demonstration on the software which will help us to get the result of our mathematical modeling. Okay, So I'm going to share my screen. Once again, I thank all the members of Dr. Vithalrao Vikhe Patil College of Engineering, Ahmednagar. I'm happy to tell you that I was also one of the employee of this college in 2005, and I really love environment and teaching there as well. So I'm also one of the part of your journey. So I'm going to share my screen. Just somebody will confirm my screen is visible or not.
Yes, sir. Yes, it is visible, sir.
So today's session, I'm going to talk on the mathematical modeling approach. So as an engineer, when we learn different concepts, concept in thermodynamics, concept in strength of material, concept in any form here, most of the things are associated with the mathematics. And once we address that one, then we'll come with some certain solution and we can find out something is happening with that one. Okay, so before starting up this particular presentation, just observe this figure. And my question on this figure is that this figure is possible or not. There is a chat box. Just put on the chat box that yes or no, so that I can understand the figure is possible. This model is possible or not. Just take a slide 30 seconds. So as we are going to use a technology. Definitely, technology itself has some certain challenges. But if you look at this particular figure or the model which has been mentioned here, it's a kind of illusionary figure. It's kind of illusionary model. If you start from one corner and start to finish with the end, then you will come to know that model is not possible. So it's kind of illusion. Similarly, in the mathematical modeling, if you are able to generate the model, you will feel that everything is looking like as an illusion. And once you are confident in your model, then your model will start giving out the solution. So this is the concept that today I'm going to explain you about the approach, how one should look at solving the engineering problem in a in spite of traditional way, how the mathematics can be involved. And once you start preparing your mind how mathematics has been associated with each and every statement, then it becomes easy to formulate the problem. Once you formulate the problem, you can find out the solution. And the role of engineer is to first frame the problem, and based on the problem, you are going to find out the solution, how the object look like. This is how the mathematical approach comes into picture. So in today's presentation, I'm going to give you some basic introduction about the modeling, concept of geometric modeling, types of modeling. The most important concept today I'm going to emphasis is on mechanistic modeling, which is the combination of your analytical modeling as well as the stochastic modeling. Followed by a concept, I'm going to give you one case study and the famous dimensional modeling concept, how it can be useful for the problem where you cannot solve using your conventional way. Then this approach can be explored. And with the help of all this concept, I'm going to cover some example mainly associated with the data fit. I'll be focusing on. If time permits, I'll consider on the design expert as well. So this is the flow of my presentation. So coming to the modeling, since our childhood, we have been acquainted with the various kind of models, and we try to imagine ourselves that how we can do this one and what exactly it look like. So the concept of modeling is that the art of abstracting or representing the object, system, or phenomena. So modeling itself gives you just a replicate or a physical model, or it describes the system, how the system look like, or a phenomena, how the particular environment or how the system or the phenomena exhibit. So modeling is the art of abstracting, means what are the concept is exact which you are going to implement, which you are going to execute. Before that, some kind of abstracting has to be present, and based on that abstracting, just elaborating one by one more terms, you can get the entire phenomena. So model is a description of a system designed to help on an observe designed to help an observer to understand how it works or predict its behavior. See, as an engineer, when we are talking about the model, why there is need of modeling for an engineer? Because when if any car has to be designed, so the problem statement will be given that so somebody has to design a car of so and so sitting capacity with so and so horsepower with so and so fuel economy or something. So in this way, the problem statement comes into picture. Now, once the problem statement comes into picture, then we have to identify, as an engineer, we have to identify what are the influencing parameters, what are the essential parameters, what are the dependent parameters, what are the independent parameters, what are the forcing factor which helps to generate this component or function this component. So, so once the problem statement has been given to you, then it has been discretized in a simple way, and a simple individual model has been addressed, and by combining together you can come with the exact solution. So models are typically conceptual and existing as an idea, a computer program, or a set of mathematical formula. So not necessarily a model is a physical object. It can be a program, it can be your mathematical formulation equation, the best equation that we know since our childhood, the equation of circle. The equation of circle is pi r square. So r is the is the radius. So pi r square is a generalized equation for the circle. Obviously, all of you know that it has been determined based on the stochastical method, but this is the basic. So it can be any mathematical formula. Model can be a physical object which helps us to realize or correlate how the existing system will look like. This is the main theme of the object. Model can be an actual physical object such as small scale aeroplane model used to test the performance or full size aeroplane. So nowadays a lot of computational systems are available, but in earlier case people used to generate a prototype for boiler, prototype for car, and based on doing some lot of trials or some testing, it has been scaled up, and the final component of the object comes into picture. So in short, the model, the art of abstracting or representing the object, phenomena, or a system. The main purpose of modeling, it is used for prediction, how the system, how the object, or how the phenomena will function when it comes into working condition. Okay, so the main role of model, when the problem statement has been given, the engineer has to find out the generalized model. Modeling has been done for prediction purpose, how the system will work when it comes into execution. So this is how the modeling concept comes into picture. Now, to understand the modeling, some terminology is there. There is two systems come involved here: primary system and secondary system. The system under study is called as primary system. Suppose if you're going to work on the development of a new automobile car, so automobile car itself is the primary system. Any aspect to this primary system that that an investigator uses to study the system means, as the car has been used for a passenger or individual person, or it's a goods carriage or car or something, then whatever the system associated with this one, that becomes your secondary system. And working on the secondary system, finding out the solutions for the secondary systems, and assigning this secondary system together, that gives the solution for the primary system. And this is how your exactly mathematical modeling comes into picture. So the data or a graph representing primary system then will become the secondary system. Model is a secondary system used to verify the hypothesis on the primary system. Now, once problem has been defined, then the engineer or the designer has to predict some certain hypothesis. Suppose this car can be capable of handling so and so capacity of load. So this handling of the load how it will handle means it will initially provide a hypothesis that it is going to handle so and so load with so and so capacity. Now, to achieve this one, the engineer has to provide a secondary system, And at the end, if the hypothesis is proved, your solution will come into picture. If hypothesis is not proven, then you will come to know that what are the hypotheses or what are the assumptions which initially has been designed that is not able to solve the mathematical problem. So in this way, the mathematical problem solution comes into picture. So the essential thing is that primary system where we are looking for the solution, but to achieve the primary system, some secondary system has to be generated. Finding out the solution for the secondary system, combine these together, and which will give the address for the primary system. Now coming to the part of geometric modeling, the important concept of modeling of anything, modeling, maybe a mathematical model, maybe a geometric model, maybe an analytical model. It is used for general prediction or how the system look like, for just assumptions, how the component will look like, how the system will look like when it comes to the functioning, how it will function. So for this purpose, the role of mathematical model comes into picture. Okay, so there are different modeling concepts are there. Some models modeling concepts which directly useful for give the real feel of the object. The geometric modeling is one of them. The complete representation of object with graphical and non-graphical information. So this is a typical definition of geometrical modeling. Means you're going to use some graphical elements. You're going to use some some curves, some analytical entities, synthetic entities, which helps to represent the object. And once you able to represent the object, then you will come to know how the system will look like. And further, nowadays, a lot of things are available that these models can be used for analysis purpose, for testing purpose. So geometrical modeling concept means which use some graphical elements like line, curves, arc, cylinder, some primitives. Based on these primitives, the physical model can be generated, and this physical model will give you idea how your object will look like. And based on that, you can work on the aesthetic, you can work on the ergonomics, and you can achieve the final component or final model. Okay, so geometric modeling is as important to CAD as governing equilibrium equation to the classical engineering field. So I think all of you know that there are some standard governing equilibrium equations for classical engineering. So most of these governing equations are based on certain assumptions or based on some stochastical approach. But that governing equations like Bernoulli's equation, like 1D steady-state heat transfer equations, these are the equations. These are the classical equations. Why it is called? Because these are the equations are useful for generalized application. These are the systems. Once you change the one or two parameters, you can easily identify or by varying the input output parameters, you can easily identify or understand how the system will work. And these classical engineering governing equations are generally based on certain assumptions. Okay, so nowadays another approach is coming that eliminating the approach assumptions and try to add some more terms in the classical equations, which gives you the modified equations. And in this way, the mathematical modeling goes on. And this is possible because nowadays a lot of computational powers has been improved, and with the help of computers or with the help of some certain mathematical softwares, one can find out the doing multiple iteration, one can reach to the solution. So this is how the modeling comes into picture. So geometric modeling is very important whenever you wanted to go for some CAD analysis, some machining simulation. So in that case, geometric modeling is essential, and geometric modeling is a complete representation of an object with graphical and non-graphical information. Now, what are the essential requirements for the geometrical modeling? In geometrical modeling, the essential thing is that there has to be some topological and geometrical data. Geometry means generally shape, dimensions, means what are the shapes you are going to go. It may be circular, it may be elliptical, it may be cylindrical objects, or some primitives which has been used with some certain dimensions then that are associated with the topology, geometry. And the topology mainly involves connectivity and associativity, means what are the two, if you're going to use two different primitives and to generate the model, how these two different primitives has been connected to each other. And that connection is defined is known as topology. So many of the times, many of the many of you might have observed that during generating some certain models, you will get some topological error. The meaning of this topological error is that means whatever the object you are going to generate, that does not have a proper connectivity or a proper associativity. Means suppose if you generate draw a ellipse, and if you want to go for rib option and your rib radius is very small, so in that case your that object get internally mixed, and due to this internal mixing there is no connectivity happens, and as a result you will get the topological error. So whenever geometric model has to be generated, the two essential things are required, that is proper geometry, shapes and dimensions, with proper shapes and dimensions, and there has to be a proper topology. So based on this topology and geometry, one can able to generate the geometric model, and the geometric model will give you the feeling how you are looking for, what you are looking for, and based on that you can go for actual model manufacturing. This geometrical model not only used for some FE analysis, but it is also useful for generating the CNC CAM or toolpath program. So this CAD is very important for CAD, CAM, and CAE. So CAM, which generates a CNC program, which helps for generating the CNC program, and for CAE, it is used for analysis purpose. Okay, so this is a typical diagram for showing the example of topology and connectivity, and this is the universal diagram, and everybody is familiar that if you look at the first figure and second figure, first figure shows the same geometry with different topology. So the connectivity of the circle is from the inside, here connectivity is from outside. So you're going to get the two different objects. But with here same topology with different geometry. Geometry means your angles are different, lanes are different, but the connectivity is from inside. So this is a typical example of how one can understand what do you mean by topology and what do you mean by geometry. But this is very essential for understanding how your object will look like. If you don't have a proper topology, you will get the error, and with the help of that you are not going to reach to the final solution. So this is how the geometric modeling comes into picture. Geometric modeling mainly based on the some certain graphical data, some primitives, some curves which has been used for generating the geometrical model. So this is also one of the type of modeling, but which gives you a realistic approach how the object will look like. Okay, so this is a basic concept that most of the students learn in the CAD/CAM on something subject. Now coming to the actual part that we are looking of the modeling concept. So coming to the modeling, in mathematical modeling, there are two approaches comes into picture. One is analytical modeling, second one is numerical modeling. In analytical modeling, the analytical curves, analytical operations comes into picture, and in numerical modeling, the simple arithmetic operations comes into picture for finding out the solution. Another modeling is stochastic modeling, which involves regression modeling. Second one is empirical relations. So governing classical equations mainly based on the analytical modeling concept. But to derive these classical governing equations, some certain assumptions have been mentioned. So if you look at here, one-dimensional heat conduction steady state equation. So in that case, it is mentioned that it is assumed that there is no internal heat generated. So similar kind of whatever the standard governing equations are there, classical equations are there, all these equations represents a typical system or a phenomena which are used for prediction purpose, but these are based on certain assumptions. Now what happens in if you derive a system based on some certain classical governing equation, and when it comes to the function, you will find out a lot of some results are not matching, then you will come to know that some certain assumptions are has to be eliminated. But some certain assumptions has to be eliminated based on some experimental data, and with that experimental models, the model based on the experimental data comes under the category of the stochastic modeling, which mainly involves regression, and second one is empirical regression. If you know the behavior of the system, most of the times people are going to go for the regression equation. But in case if you're not able to know how the system will function, how the system will behave, then in that case you have to go with some certain empirical relation. You have to assume some certain empirical relation, try to prove that empirical relation is correct based on the experimental data, and accordingly you will come with the some new equations, and that new equations gets to be added in the analytical equation. So I'll explain you this part in a due course of time. So this is the typical types of modeling. Mathematical modeling involves analytical, numerical. Stochastic involves regression and empirical. So combination of mathematical and stochastics, which leads to the new concept, that is mechanistic modeling. And most of the people are working on this one, and that will helpful for generation of new concepts. New models has been generated with the help of this mechanistic. So the role is that mechanistic model is that what are the assumptions associated with the mathematical modeling. If that assumptions, if we are going to try to eliminate with the help of this stochastical or some experimental data, combination of this stochastic and analytical generates the mechanistic model. So this is the new approach that comes into in the many researchers are there following this mechanistic approach, and sometimes, or rather many times, this mechanistic model helps to predict the result. Only the limitation associated with the mechanistic model is that this mechanistic model will work in a specific domain. This mechanistic model cannot be a generalized model, whereas analytical model, numerical model can be a generalized model. So major limitation associated with the stochastic and the mechanistic model is associated with the, it has some certain limitation with starting with input and input range, and which definitely useful for prediction of some certain output range. So these are the three different mathematical mathematical modeling techniques. Now in our presentation, I'm going to describe one by one. So as all of you know that analytical models can be broadly defined as the formulation or equation that express the essential feature of physical system or process in mathematical term. So any mathematical model, it defines, or it is based on, it requires some certain physical system or the process. Means suppose anything is coming from top and it is falling on the ground. So it is due to gravitation. So physics is involved. So based on this physics, the gravitational law comes into picture. So for generation of any model, the physics has to be there, and by understanding the physics, it becomes easy to for preparation of this model. These models are built with interrelated sets of equations, which may be algebraic differentiation or differential equations with logical statements and constants. So here, if you look at here, which involves your algebraic operations, differential operations, integral operations. So using this one, you're going to find out the entire model, and that model will be useful for prediction purpose. So the role of analytical model is that it based on physics of the system, and which involves the various operations or different equations, which may involve algebraic, differential, or statistic, or integral, like this. So this is the typical role for generation of the analytical model. Now, development of analytical model itself, if somebody understands the physics, then the model can be generated smoothly. If one is not able to understand the physics, how the system will work, then it becomes very difficult to find out to generate the analytical model. General term associated with the analytical model is the dependent variable is the function of independent variable, parameter, and forcing function. Now, independent variable that are essential. Parameters means which influence their output performs, and the forcing function means which are essential to drive that particular phenomena. Means the physics mainly associated with this forcing function of any analytical model. So there are some certain example of analytical equations. That equations are steady state heat conduction, Bernoulli's equation, Newton's law of cooling, Ohm's law. If you look at here, Newton's law of cooling, Bernoulli's equations. So for this particular equations, some certain physics is involved. And based on that physics, looking into this particular parameter, the equations are derived. And these are the standard equations that everybody knows. These are the classical governing equations, which plays a very important role in engineering. But if you look at here, heat transfer conduction equation, heat flux is directly proportional to temperature gradient. But if this formulation has been done, initially assumption is there is no internal heat generation. So similar for Bernoulli's equation, the fluid is compressible fluid or something. So and in this case, based on these assumptions, the generalized equations are being prepared, and these generalized equations are useful for prediction purpose for generalizing phenomenon. So these are typical examples which comes into the category of classical and based on the analytical operations. So which involves differential equations, which involves some algebraic equations, and which helps for prediction purpose. This is another Newton's law of cooling. But if you look at here, all equations involves physics, and once the physics has been understood, accordingly the equations has been framed. Now, to give you the correct flavor of analytical model, I'm going to give you an example here. This is a typical example, a task of prediction of a velocity jumper, which is given in the figure. This is a figure. I think all of you know this is a bungee jump kind of activity where the string has been tied to the foot of the faller, and accordingly the this jumper takes jump from a high level, and with the help of this one springing action, he can enjoy the adventure, that part. So the task of the predicting the velocity of the jumper as a function of time during the free fall of the free fall part of the jump is given. This information will be used as a part of larger analysis to determine the length and required strength of the bungee cord. So this is the bungee cord. The main problem is that in this particular problem, it is proposed to find out that what should be the length of the bungee cord and what should be the strength of this part. So this is the problem statement which has been given here. From the physics law, the acceleration should be equal to the ratio of the force to the mass. This is Newton's law. So based on that, based on this your analytical equation, it comes into picture where G is your gravitational acceleration, this coefficient of drag. So in this way, this is the typical analytical equation which has been here generated here. By solving this, your regular analytical form, this is the problem statement. By solving this particular equation using some taking integration from both sides, dt on this side, evaluating with the minimum limit and maximum limit, the velocity formula, by solving this one, the velocity formula using analytical equation becomes like this. And this velocity with respect to time. So by changing the time, you're going to get what should be velocity of time equal to 0, time 1, time 2, time 3 accordingly, or time goes to the infinity. So the problem statement is somewhat like this. A bungee jumper with a mass of 86.1 kg lifts from a stationary hot air balloon, which is given in the equation here. So what different coefficient of drag friction is given here, G is given, and time you are going to get in this particular problem. By putting this known values in this equation, you are going to get the, with reference to if t equal to 0, what should be the velocity? If t is equal to 2, accordingly by putting this value, you're going to get the velocities here. So this is a typical analytical modeling results. The important thing associated with the analytical modeling gives you the exact result. This is the good part of analytical. So people are focusing on that, how they can reach to the exact analytical modeling, and because that helps to give the exact result. Okay, this is another example. This is a typical operation research problem where a manufacturer firm produces 2 machine parts using lathe, milling machines, and grinding machines. The different machine time required for each parts, which is given here. So lathe machine for part 1, part 2, and this is the time available for lathe machine. This is time available for milling machine. for grinding machine and the profit per part which has been given here. So this is a typical simple algebraic equation. The main object. This is a typical problem statement which will be given to the engineer. In earlier case, the problem statement is that one has to find out the length of the bungee cord and one has to find out the strength, and based on that, some relation associated with the velocity comes into picture. Based on that, formulation has been done. Now this is a typical operation research problem, optimization problem, where one has to go for maximizing the profit. And this problem statement can be easily formulated with the help of some mathematics involved here. So these are the typical examples. These are the typical mathematical problems which every engineer has to come based on this logic, based on the mathematical operations, based on mathematical equations. One can be able to formulate the problem. Once one can be able to formulate the problem with the available data, one can able to solve the problem here. Okay. Now coming to the next category of mathematical modeling, that is numerical modeling. This numerical modeling is concept is that, as I mentioned that earlier, we know the equation of circle. So it's a typical example of pi. A circle has been discretized in a small way, and by adding the area of all that part, the mathematical model, that numerical model has been generated. So numerical models are the technique by which the mathematical problems are formulated so that they can be solved with arithmetical and logical operators. So the important thing is that in numerical model, that with arithmetical and logical operations, these all problem has been solved. Means there are some problems which cannot be solved using analytical one. Rather, for the problem, it becomes very difficult to generate the analytical equation. That problems can be addressed with the help of numerical model. In numerical model, what happens? The problem has been discretized. Once the problem has been discretized, it becomes a small. Then when it becomes a small, you can use normal mathematical operations, and by adding this all together, you will get the entire result for this one. So all FEA software works on the numerical method. The important fact associated with the numerical model is that it does not give you the exact solution. It does not give you it gives you the approximate solution. The role is as an engineer, our role is that we have to try to minimize the error which has been generated in the numerical model. The same problem of bungee cord, which can be solved using a numerical model. What just look at here, numerical model techniques by which the mathematical problems can be solved using arithmetic and logical operations. Here, this is the typical. Just a minute. Yes, I just. My voice is audible?
Yes, sir. Yes, sir. You are audible.
Okay. Now, same problem has been solved using a numerical method. Just with the help of some simple differentiation formula, it has been divided into this first stage, initial velocity, then next stage velocity, and then accordingly, the using this relation, the velocity at different location or different time, it has been generated in this way. And if you look at here, it involves only simple this is the formula which has been used for numerical method for calculating the velocity at different stages. And if you look at here, this is a simple formula which involves simple arithmetical and logical term here. Means velocity, initial velocity that you know, when jumper start, initial time is equal to 0, so that will give you the velocity at time t is equal to 0. Accordingly, by discretizing the time, you can find out the different intervals, and you can get the solution. So this is the formula which helps to find out the velocity for different time interval using numerical method. Whereas earlier formula was this one. This was the formula which has been used for analytical method, and the formula which has been used for numerical method is this one. So same problem has been discretized, and with the help of numerical method, it has been solved in this fashion. And now if you compare the result here for different time, if you compare the result with the analytical, this is the line which has been obtained here. This is the with the analytical one, but with the numerical one, with the different interval, you will get a lot of difference, and this is called error. And this error can be minimized by reducing this interval. So once you reduce the interval, the error try to get minimized, but still there are some errors which has been associated with the numerical formula. So starting point and the end, your answer is exactly matching, but in between, due to this interval, error has been introduced in the numerical way. But the same problem which has been addressed with the help of this is the solution which has been obtained using a numerical method, and when it has been compared in this fashion, you are going to get with this is the solution which has been obtained at analytical one. This is the solution which has been obtained with the numerical one. Now, as this is a typical problem which can be addressed by both way, you can easily compare the solution. But there are some certain problems which hardly difficult, or rather which are difficult to address using analytical one. Then so that kind of problem can be solved with the help of a numerical approach. So this is the general difference. Analytical problem is generally used for simple geometry. Uniform and homogeneous properties are essential in ideal boundary condition and ideal initial conditions, but the theoretically perfect solution is obtained with the help of analytical one. But when we compare these ideal cases, in actual case, it doesn't happen. So in sometimes, with the help of this analytical concept, by mixing with the numerical one, we can find out the solution for it. Numerical solutions has advantages that it can have, irrespective of irregular geometry, it can provide the solutions. Not necessarily the homogeneity is required. Anisotropic problems can be addressed. So, this numerical, but the important fact associated with the numerical modeling is that it is a approximate result. This is the approximate result. So these are the main two comparison associated with the analytical one and numerical one. Now coming to the stochastic modeling, which is very important, and nowadays many researchers are working, because once some hypothesis has been generated, to execute that hypothesis, some philosophy has been prepared, some experimentation has been designed. By using uncertainty analysis for the experimentation, experiments were conducted. Once the data is available, using this regression, one can generate some certain modeling. Nowadays, we are living in the era where data plays very important role. Wherever you go, you will get everybody is talking about the data analytics. Everybody is talking about the data analysis something. So that nowadays that data is very important, and that most of the data analysis involves regression equations, maybe linear regression equations, second order polynomial, multivariable regression equations. So today we are limiting up to some certain variables, and we are going to understand what exactly concept. Most of the concepts everybody is knowing now. In today's session, I'm going to mix regression equation with the analytical equation, which generates the mechanistic model, and which certainly useful for prediction purpose. Mainly those who are doing research, those who wanted to do research, this is one of another important aspect for generation of the mathematical model. So this is a typical regression analysis, that formula, a technique for determining the statistical relation between the two or more variable, where a change in dependent variable is associated with and depends on a change in one or more independent variables. So this is a typical formula, which is y is your response, x is your input. So one input, one output, one can easily plot on the Excel. Excel gives you better solutions for this one. But this is the typical formulation which helps to for generation of this regression equation, and this is a typical linear regression equation. Let us consider this is the input data, this is the output response. Then based on this input and output, one can understand what could be the relation comes into picture. So I'm going to show you one. one simple example in Excel that everybody knows that one, but suppose this is are you able to see the Excel screen? Can anyone confirm? Can anyone confirm that are you able to see the screen? So this is a typical Excel.
Yes, 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 we can see that. Yes.
Yes, this is the input. This is the output. So using Excel, there is a lot of.
Yes, sir. Yes, we can see, sir.
Yes. So a lot of scatter range is there. So you are going to get this equation like this. So if you click on this one by using add trade lines, you will get some different regressions here. So the one is linear, second is logarithmic, third one is polynomial, third one is power law, and next one is moving average. So based on your equation, and if you turn this equation on, display R square. I'll just close. Add trade lines. This is a linear equation. If you want to see the equation for this line, then display the equation on the chart. So this becomes the equation for this line. So maximum points which has been passing from this line. But looking at this particular graph, it doesn't seem to be so it becomes an exponential equation. So this becomes a mathematical model. This becomes your input is X, output is Y, and if this matches here, and if you want to see how whether it is matching or not, then you need to identify the R square. That R square is called as coefficient of correlation. That coefficient of correlation determines whether how your solution is close to the exact model. So this is the R square. It is expected that the value of R square should be equal to 1, but in most of the experimental case, it doesn't happen. So, but it is statistically, it is accepted that value of R square is greater than 0.9, then your equation is acceptable. So this is the exponential equation. So similarly, there are different equations which has been available here. Polynomial equation is there, power law is there, moving average, logarithmic. So these are different equations, and for every model, these now Excel has the facility that it has an internal regression analysis, and based on that, it generates these particular equations. So based on that, this is a typical example. But in this case, one input, one output. But in real cases, we have multiple input, multiple output. Then how to address that part? That I'll come to that part in my presentation. So this is the typical example of regression analysis, which is with the help of Excel nowadays. It helps easy to identify the output regression equations. Once you get the equation, use that equation for prediction purpose, or you can mix that equation with the analytical term. Then accordingly, you can modify the analytical equation. This is how the new equation can be developed. Another equation which involves in the mathematical modeling is called as empirical relation. Now, this is very important thing. In many of the hypotheses, the hypothesis is governed by many input parameters. Not it doesn't have only one input and one output. It may have one multiple input, multiple output. Now, in that case, it becomes very difficult to identify or to see the influence of which parameter has more on the mathematical function. In mathematical function. So in that case, most of the times researchers are using empirical relations. I think all of you know that in a natural system phenomena, very few system passes from the origin. But many system has some certain threshold. Means if you start something, it doesn't passes from the origin. So there has to be some certain threshold, and that threshold has to be associated with the constant by adding a. Then you're going to, whatever the input parameter which you have, you will use some empirical relation in this fashion. This is the arbitrary equation which you have chosen. Not necessarily that one should go for this equation. So the other should go for a different equation like this. I'll just share one whiteboard. What are the equation which has been given as suppose the speed is equal to a into v raised to b into f raised to c. One can go for a different equation if you know some basic phenomenon based on literature. One can go for some equation like that: a into e raised to v raised to b f raised to c. One can go for if you look at here at by putting value of input parameter equal to 0, your output does not passes from the origin. Then one has to use some one plus some arbitrary equation. If you can use some constant plus some arbitrary equation. So for generating empirical relations based on the literature review, one can identify how your hypothesis is going to predict or how it is going to work. Based on that, these equations are very important, and these equations are called as empirical relations. You're going to find out some empirical relations with the experimental data. Put that experimental readings in this empirical relation, try to find out and prove that your empirical relations are correct. If your empirical relations are not correct, then one has to go for finding out the different arbitrary equations. Perform. You have already experimental data, fit into this one, and in this way, you're going to find out the. But generally, the thing is that generally the thing is that when you go for some empirical relations, these relations are preferred when you do not know what will be the input, what will be the influence of input parameter on the output. So in that case, the empirical relations comes into picture. This is a typical example of power law. Power law means you're going to use some powers and identify whether which factors having which influence. But by using initially power law, it helps to predict. It helps to predict what is the influence of one parameter on other, what is the influence of one parameter on output. And by correlating the power of these two, one can easily identify which factor is dominating on the output. And nowadays, it has been observed that this empirical relations plays a very important role in most of the research community. Because if you do not know that your system behaves linearly or a second order polynomial with third order polynomial, then it's always easy to use some empirical relations. Find out based on this power, one can identify whether it's a linear, polynomial, quadratic, something. Accordingly, you can once again generate new equation and come with the solution. This is how the stochastic, and this solution for this finding out value of A, B, C, there are a lot of softwares are available which helps to find out this solution in a very, very short time. So empirical models are based on the direct observation, measurements, and extensive data records. So these are the difficult. So these are some examples which has been used. Now, in case of empirical and any stochastic model, the conformity test of that model has to be done. And another important fact associated with the empirical and stochastic model that these models are valid only for a specific domain. When it has some minimum limit, it has a maximum limit. Within that domain, these models are acceptable. If your domain exceeds your value of input or output or input exceeds beyond your limit, then this model will give the answer, but may not 100% confident that it will give. So confirmation test has to be within range. So I'm going to give you one best example. These are the different test sets. Cutting force. This is a typical empirical relation which has been used to predict the influence of cutting speed, feed on output parameter like cutting force, surface roughness, tool wear. So this is a typical example which has been used. A lot of experiments has been conducted. The accuracy of empirical and regression model is mainly dependent on the data set. It requires large and huge data. And if it has a large and huge data, then the reliability of this model is very, very good in this case. Now I'm going to explain you the concept of mechanistic model, and during this mechanistic model, I'm going to show you some demonstration with some certain tools here. The mechanistic model assumes that the complex system can be understood by examining the workings of its individual parts and the manner in which they are coupled. Mechanistic models are based on the understanding of the behavior of the system components. Mechanistic models typically have tangible and physical aspects in that system components are real, solid, and visible. Now, mechanistic model, what exactly it does? In a particular system, some certain basic assumptions is there. Let us consider if you're going to go with the this steady state heat conduction problem, and in that case, it is assumed that there is no internal heat generation. But due to some functioning, it has been due to some inter-surface contact, due to some rubbing action, heat is generated. So as heat is generated, that law cannot be used in this case. So to modify that, if you know that you are going to working on a particular hypothesis where you found that there is a rubbing action between two surfaces and heat is generated, then you can modify your assumption that internal heat is generated. That internal heat relation has to be performed based on some certain experiment, and that component has to be added in that equation, and you can get modified mechanistic equation. So in this way, the modified equations can be generated. I'm going to explain you one best case study. As I am from manufacturing background, so I'm going to use a case study associated with the cutting force model. I think all of you know in machining operation, this is a typical machining or turning operation in which this is a workpiece which has been used here for machining purpose. A lot of forces are generated, and as force due to this different two materials are there, the sliding is taking place. So there is rubbing action is taking place. So internal heat is also generated. So and this is a high strain working environment. So we're going to find out a mathematical model for this cutting force. Important concept associated with the mechanistic model is it is a combination of analytical model and a combination of statistical model by modifying one of the assumptions, and by the modification of that assumption is determined based on some experimental data. Based on the experimental data, statistical equation has been generated. By merging the statistical equation with the analytical one, modified equation gets generated, and that modified equation has been tested rigorously whether your that model is valid or not. This is how the mechanistical model comes into picture. And now most of the researchers right now are there focusing on this one, development of mechanistic model by eliminating some certain assumptions and making the system more realistic. So this is a typical example that I'm going to explain you. This is I'm going to explain you the cutting force model where I'm going to use Taylor's cutting force model, which has been based on certain assumptions, and I'm going to eliminate one of the assumptions and try to eliminate the one of the assumptions and generate the modified equation for the cutting force. Cutting force is one of the influencing parameter on the machinability. Machinability mainly associated with how easily the material can be machined. That term is called as machinability. Analytical model for the cutting force provide the solutions for the simple geometry. If your geometry is simple, you can easily find out using analytical model. You can easily find out this one. Empirical model for the cutting force can be used only for selective range of cutting parameters for a particular tool, and the mechanistic model is a combination of analytical and empirical model. So here I'm going to propose, or I'm going to show you the case study of how the mechanistic model can be developed. But also it also governs a lot of parameters. So we'll come to that part one by one. This is the typical merchant's theory, which has been used. This is a merchant circle which has been proposed, and which helps for finding out the cutting force. But this particular merchant model, which is used for orthogonal cutting, what are the different assumptions? Assumptions are the cutting has to be orthogonal cutting. Means tool is perpendicular to the direction of feed. Tool geometry is perfectly sharp and has no corner contact on clearance face. No internal temperature is generated here. See, now if you observe here, during machining happens, due to this cutting, shearing is taking place, and due to shearing, heat is generated. And the assumption mentioned here that there is no internal heat generation. So obviously, what are the result with this model is not the true results. Okay. So what in this particular case study is proposed that it is presumed that internal heat is generated, and that heat is being determined by various techniques, and the cutting force model has been modified. No side flow chips, continuous BU, no BU is there, work moves with uniform cutting velocity, uncut chip thickness is constant. So these are the assumptions. You look at here, these are the assumptions based on that one cutting force which is being used. These are the different parameters. FC is the major cutting force which we are which is of our interest. This is shear force. These are the different cutting field, depth of cut. These are terminologies which is being used, which is known to everyone as per the merchant circle is concerned. So based on this one, based on this particular theory, the cutting force which has been proposed by merchant is in this way. TS is your shear stress, chip cross-sectional area, the beta is your friction angle, gamma is your crack angle, phi is your shear angle, which has been mentioned here properly. And this is the cross-sectional area, chip cross-sectional area, and the shear stress. Now in by knowing this one, one can easily find out the cutting force. What is the cutting force which has been required? Now in cutting in determining the shear stress, the distortion energy theory has been used, that is called as one masses theory. Based on this shear stress is determined by this one, where sigma y is your one masses equivalent stress. Now, all of you know that this cutting is taking place at high speed, and high speed, shear strain has been generated here, and at high strain rate, the material property changes. What are the stress strain curve that we are going to get at a constant strain rate? But when the strain rate changes, the value for sigma y, sigma x changes. And that is been determined by using different model. That model is called as Johnson-Cook model, which has been used here. In metal cutting, strain rates found to be in the order of 10⁻³ to 10⁵, which is a very high strain rate, and higher strain rate, your material property changes. It is observed that at high strain rate, the yield strength of the material increases with respect to ultimate stress. So this is a very important part, and which is not been considered in this particular mathematical modeling. So to give the result for this one, in present work, the Johnson-Cook constitutive equation has been used. Now this Johnson-Cook model, what it covers the high strain rate, temperature generation, and stress to the whatever the strain rate comes into picture. It measures the stresses, and it determines you the value for sigma y. So Johnson-Cook model has been used here, and based on this experimental data, there is one empirical relation which has been identified for the tan phi. Phi is your shear angle. Based on this particular part, with reference to cutting speed, depth of cut, this phi is determined. This phi is important for calculation of this cutting force here. But this phi is determined based on the empirical relation. This temperature is also been determined with reference to some empirical relation here, using some temperature cutting. So this becomes your empirical relation for the temperature. This becomes your empirical relation for the phi. This phi is a part of your cutting force equation. Temperature is the part of your Johnson-Cook equation. So this is the temperature which has been involved here. This is the Johnson-Cook equation which has been used. This equation has proven that at higher strain rate, the value of sigma yield stress changes. And this is a typical SS304, which is the material which has been used. These are the value for Johnson-Cook equation. These values A, B, A, and C are determined using one test that is called as split Hawkinson's bar test, which has been used. And using this value of sigma has been determined for this different strain rate. And once the value of sigma has been determined, that value of sigma here, which helps to find out the value of shear stress, that shear stress value will be substituted here, and empirical relation for this phi and temperature has been added. Why temperature has been added? Because internal heat is generated and that heat has been considered here. Okay, so accordingly the equation get modified and you are going to get a new equation for the cutting force. So this is the based on this one, the developed model, cutting force model is this one, modified model. And this model, once the model has been determined, based on, it's a combination of empirical relation and it's a combination of your regular analytical equation, and accordingly the modified the equation is being generated, and with the help of this modified equation the experimental data and model data has been evaluated, and you will find out the error has been observed within the range of 10 plus minus 10%, and that shows that your model is acceptable. But the important thing is that in this model, with reference to specific strain rate, if you put the value of A, B, C, N, then most realistic results are obtained. And so in this way, the mechanistic model has been developed, and this FC mechanistic model, which is a combination of analytical equation as well as the empirical relation, which is empirical relations are based on some certain experimental results, and combination of these two. Now this model is only applicable for the range from 140 to 320, means in between whatever the parameter comes into picture, this model will try to give you the exact result. But if parameter exceeds beyond this one, then it becomes difficult to get the result. This is how the mathematical model comes into picture. Sir, how much time is required remaining with us? Time. So last 10-20 minutes are remaining. So I'll quickly go through the this slide. This is the typical dimensional model which has been used for temperature. I'll quickly run through this one because I'm going to show you one demonstration on the data set. So this is temperature. This is a.
Sir, you can continue up to 11:30. No problem.
Okay, but 20 minutes are remaining. Na? So this is the typical experimental setup which has been used. Some regression analysis. Now, measurement of temperature in any machining process is very challenging part, and a lot of theories, lot of research is being still going on there to predict, because that temperature plays very important role on machinability or improving on the tool life. So, so dimensional analysis approach which has been used, the parameter which has been considered for a dimensional analysis, there are some certain steps which has been involved. Selection of the fundamental quantities, it requires fundamental quantities and physical quantities. So fundamental quantities, mass, length, temperature, and time, and physical quantities which has been involved here. It is assumed that 85% of the heat which has been disposed along with the chip, hence the thermal conductivity of the chip is omitted. So heat is not been transmitted in the job or workpiece. So it has been considered here. Dimensional formula for temperature, cutting speed, cross-sectional area of chip, specific cutting pressure, thermal conductivity. These are the physical quantity which is of our interest for measurement of temperature. So selection of this physical quantity is very important in case of temperature. Then dimensional formula which has been used here. Then using dimensional analysis process. Basic variable, 4 fundamental quantities, 4 number of variables. So according to Buckingham 5 theorem, 2 equations has to be generated. So the 2 groups which has been generated based on the physical quantities, Q1, Q2, which has been converted into a dimensional part. By solving this one, Q1, you will get these relations, and based on this, some experimental results which is available here, the temperature relations which has been determined. Value of COM, these are different for different cutting, different material. Value for CM, N, these are the constant for these equations. These are different for different cutting tool materials, and based on that, you're going to get the empirical relations for this one. And this dimensional, obviously, one has to ensure that whenever the equation, mathematical equation, you're going to go either analytical one, either mechanistic one, numerical one, or dimensional one, that has to be correlated, or confirmation test has to be done. Then only that will tell us that your model is correct or not. Okay, so this is a typical approach which has been used. This is a standard process for dimensional analysis, where now in case of cutting force, a lot of equipments are developed, but in case of temperature, it becomes very difficult to predict. So this is another approach which helps for generation of this dimensional analysis. So this is the comparison which has been done here. So in my presentation, what I have covered, the what are the different approaches for mathematical modeling. Whenever a problem statement has to be come in front of you, one has to identify what are the input parameter, what are the output parameter, and then based on some certain literature, one has to identify what are the physics of input parameter are involved in giving the output, and based on the physics, one can able to formulate the analytical equations. One can able to find out the regression equations based on the experimental one, and one can find out the mechanistic equation. So this is the approach one can use for finding out the solution for the problem which is available here. But in my opinion, if it becomes difficult to form the analytical equation, try to generate the empirical relations, mix that empirical relation with the physics of the phenomenon, and try to generate the new mechanistic equation. And this is how, and sometimes, or rather many times, this mechanistic equations works provided you provide the correct input data for this one. Okay, now as I mentioned that in regression equation or empirical relations, if you have data, if you look at here, this is a regression equation for, or this is the data for finding out the temperature, tan phi, or this phi shear angle, and this temperature. So input is cutting speed, feed, cutting temperature, cutting force, and chip thickness. So if you look at here, for this one, for getting shear, 3 inputs are there, and for temperature, 2 inputs are there. So how this empirical relations has been generated? So I have one software. That software name is called as a DataFit. I share the link with the organizers as well. So you can try this one. It's very simple, easy, and most of the research community, they are using it here. It is available for on the online for trial as well for 30 days, and one can purchase it from that software site, which is a very useful software here. So I'm using trial version here. I'm going to show you one simple example for data analysis. If you have one input, one output, this is the so best example is regression analysis, which can be easily done with using Excel. One input, one output. You simply you copy this one. Screen is visible, na? Copy this data in the Excel. You go to the graph or this is scattered. You're going to get the data like this. Okay, this is how you can easily generate in Excel. But if you have multiple input, multiple output, if you have multiple input, now this is the example where you have 3 input, 1 output. Now once you have 3 input, 1 output.
Yes, sir, visible.
Once you have 3 input, 1 output, so Y is your output, X1, X2 are the input. Okay, so once you go for solving this one, there is a regression. You have a single model, you have group, you have all model, you have loss. So it has and if you find that your problem is a typical linear or non-linear, then accordingly it has a selection linear or non-linear. You go for OK. Now if you look at here, this software has a lot of model itself. I'll first show you that. And you have own choice to define your own model. So if you want to define this is the model which shows that A into X plus B into X2 plus c into x3. If you want to define your own model, you can go for define new model. You go for new model. I'll type model name is AA. Now I will use A as a constant into x1. Your x1 raised to b. B is my unknown. I'm going to use empirical relation into x2 raised to c into x3 raised to d. So this is the empirical relation x1 raised to a into x2 raised to b into x2 raised to c. So this is and a is a constant. This is how a new model has been developed. Okay. Yes. So you are going to get the AA model. Okay. You're going to go to this model. Then once you go for select this model in this case, go for solve. Once you got the solve, immediately you're going to get the solve here. You get the model here. Then go to the result, detail. Now in this case, in this result, the important thing is this one: coefficient of multiple determination. If this value is less than 0.9, then your model is correct, or the selection of arbitrary equation is correct. Else you need to go for selection of different arbitrary equation. Okay. So as in this case, it is 0.98 because this data is proven. From this one, you are going to get the value for ABCD. So these are the value for ABCD. Substitute this value in that equation. Your equation is this one. Substitute, so that becomes your empirical relation. So A is 0.28. So Y is equal to 0.28 into x1 raised to 1.5. So now by using these parameters, 1.05, 0.17, 0.11, it shows that this B parameter, B means associated with the x1. So x1 has more influence compared to other parameters. So one can identify. Now here, if you look at here, the power of x1 is 1. So it generally shows that there is no need to go for this empirical relation. For this particular problem, linear equation may also solve your problem. Understand? So linear equation, so instead of this using this one, you can use linear equation. So, but before starting, before coming to your final equation, I always recommend that you go for power equation. This power equation will also useful for checking whether your data is right or wrong. Now I'll tell you how to check your data, whether your data is right or wrong. Okay. So I'll come to the Excel once again. I'll show you one example here. Now just this is the example for roughness. My input parameter is your speed, feed, depth of cut. This is input. Experiments are performed and the roughness has been prepared. Okay. Once the reference has been using this data fit, using this data fit equation close, I'll just go to these are 3 inputs. I'll just delete this one. I'll paste these values. I'll solve this equation, regression, A model solved. Okay. I'll see this one. Regression R square is less than 1, model seems to be okay. But in that case, suppose your model value of R is less than 80 or greater than 9.1. Just I wanted to make a correction. Your value of R square should be greater than 0.9. Please apologize me for just miscommunication. Value of R square, that is coefficient of correlation, or sometimes it is called as multiple determination. Value of R square should be greater than 0.9. If value of R square is less than 0.9, then it tells that something is wrong in your experimentation. Okay. So how to check which reading is wrong in that case? So what happens if you find it is 0.9, then copy this ABC value, put it in this equation, and generate define some mathematical formula in Excel and find out this value. And find out the error. If this error is greater than 10%, means that shows that your there is a problem with this particular equation, particular this reading. So accordingly, with the help of this empirical relation, one can also identify which reading is right or which reading is wrong. Okay, if your hypothesis is or your physics is going in right direction. So if you find that this is wrong reading, so I can conduct this reading once again and find out this new value, set in the once again data fit, find out the equation and find out the value. And if this value is greater than 0.9, then your model is correct. Then accordingly, one can go for the rating. So this is how you're going to get the error analysis. And based on this error analysis, by keeping one parameter constant, using same formulation, you can plot the different graphs. So this is how you can generate different solution. And with the help of this data fit, you can have a data table. You can also get the error for this one. This is your calculated y. This is your experimental, and this is your error. Then you can have a model plot. Then you can have a scattered plot. Most of the times, these are the statistical models which are useful for writing in the research paper also. So this is how one can go for analyzing the equations. And this data fit itself has an internal so many model. Any of the model can be helpful for. I'll just show you how many models are there new. If you go for solving the all models, so right now this is the trial version, so you're not able to see the, but it has around 200 models, mathematical models, which is being given here. So and also has the freedom that you can define your own model and find out the relations. So this is how this particular software works. So from my side, this is my last demonstration, and I hope my presentation is been completed. Thanks for being with me. I once again thank my organizers for giving this opportunity and showing some of the tricks that how the modeling can be generated. And for an engineer, if you are able to generate the model, then your market value is very high, very high, because most of the software development these are based on some modeling concepts. And if you are able to generate some model or think in a mathematical way, then for an engineer, sky is the limit. So from this one, I once again thanks organizer for giving this opportunity, for giving this presentation for the stakeholders. I hope some of your researchers can choose this approach and work on this one. That will be helpful for you. Thanks for giving this opportunity, sir.
Thank you, sir. There is one question from audience. Student Lalit Baru has asked question. So can we do same thing, regression and data fit analysis in MATLAB? Which one is better, this Excel or data fit software or MATLAB?
See, if you have one input, one output, Excel is the best. If you have multiple input, one output, Excel itself has an inbuilt tool which will solve this one. But I will recommend go for data fit, because in data fit it has a freedom to develop your own model. In Excel it won't have. Okay, so in my opinion, you go for this one. MATLAB, once your model has been trained, then you, based on that model, you can generate your geo and generate MATLAB generally used for it does not give multiple options for generating the model. But once model is there generated, MATLAB will give you the solution fastly with great accuracy. This is what I consider.
Thank you, sir. This session was great, and I think this will be helpful for the researchers, for PG students and PhD students, because many times we require this data fit and regression analysis in our research work. Okay, so it was a fruitful session today morning. So I thank you very much. Now we'll move to the second session.
Yes, thank you, sir.
Thank you. Now we'll having second session of IPR, Intellectual Property Rights, by Professor Dr. Swaspi Deshmukh. It's my privilege to introduce our next speaker, Dr. Swaspi Deshmukh, who is an associate professor in Department of Mechanical Engineering at Government College of Engineering, Karad. Sir has done his graduation from Dr. JJM COE, Jaisingpur College, Shivaji University. Then he has done his PG from Walchand College of Engineering, Sangli, and finally his PhD from IIT Bombay in 2010. Sir has served in many organizations, like from 2000 to 2004, he was in Navi Mumbai in LT College of Engineering. Then he has joined SIT Lonavala, Srinagar Institute of Lonavala in 2008. After that, he was in VIT Pune, and finally in Government College of Engineering, Karad. His distinguished services have won many honors and awards in his life. In 2012, he got Young Scientist Award for Fast Track Research Project of Department of Science and Technology. He has done work on sensorless XY flexural mechanism for precision application. In 2008, he got the award for Best Research Award for Vagniki Radiance in IIT Bombay for design and development of 3D microfabrication system. In 2007, he got one more award at International Award at Bangalore in Nano Conference for a novel optomechatronic focus laser spot submicron scanning system for microstereolithography. Its research areas include design and development of laser scanner for 3D microfabrication system and microstereolithography, flexural mechanism for precision application, vibration energy harvesting device. He has received many grants and he has done some research contracts, of which some contracts are from Department of Science and Technology, some are from ISRO, and he has done work for 15 lakh, 14 lakhs grants. And finally, he's working on one mission for sea wave energy generation pilot power plant. The finance is got from Rajiv Gandhi Technology Communication, Government of Maharashtra. Above all, some more feathers to his cap. He has published 15 patents, and 3 patents are in process. And he has published more than 50 papers in international journals, which are having impact factor more than 3.0, and all are Google Scholar Index and Scopus Index journals. So we are thankful to have such a wonderful personality. You are always motivated with your lecture, sir. So a very warm welcome to you. Now I hand over screen to Dr. Swaspi Deshmukh, sir.
Thank you, Narode, sir. Can you hear me?
Yes, sir. You're audible.
Yeah. So sound is clear?
Yes, sir. Yes, sir.
Okay. Thanks for introducing me within a long, so many statements. Anyway, I am a simple and easygoing person. So now what we are going to discuss about patents. As per my discussion with Professor Naravde, he suggested me to why cannot we have an interaction on patent filing, what will be in a patent and kind of things. Then I decided to have one session onto this, and based on that, I decided to give a brief idea about what does that patent means and why, how, and when is to be filed, all these things. So in this case, what I would like to give in a brief idea that rather than concentrating on the procedure of the patent, because procedure you can get it, that's a government procedure, and that's not a big deal for it. Actually, the thing is that most of the time we find difficult when is to be filed the patent. What is the basically idea behind the patent? So that part we are going to discuss it, and I am having some outline. I put it for my presentation. So outline is like this. So we are going to discuss first of all not about the patent, but we are discussing about the few case studies for it. So reason for discussing the case studies, is that we should know at what stage or what kind of an ideas are to be patented, and what kind of problems we people have to address during the patent. So that few case studies, maybe 3 to 4, 5 case studies I'm going to discuss. And then we are going to discuss what does that patent means, and what is the way we can go for a patenting, what its requirement, and then what are different types of patents. So many things we are going to discuss into this. So basically, I will start with case studies, and these are whatever the red color indicate those case studies I'm going to discuss. We have so many bunch of the case studies, but out of that, only these 5 to 6 case studies we are going to discuss. So one is stereolithography system, then scanner, then smart helmet, blood warmer, manual scanner, oxygenation device. There is one more patent is a multi-purpose container, footrest for the two-wheelers, and linear compressors. So many things we can go on discussing about this. So when we are going to have a patent, we patent, or I will just keep this patent word itself as somewhere away, and then we'll now discuss about how to solve the typical engineering problem. So I will give one simple example, that is a helmet. So even we are having a compulsion in the government to wear a helmet, people are very reluctant to wear the helmet. And obviously that is people are again drinking, driving the vehicle. Obviously there will be accidents caused due to this. So many things are going to happen, but nobody has started what should we control it. We can apply the rules, and we can ask the driver, show us your license, and so many things we can ask. But the thing is happen, most of the time whenever the vehicle, that person is going to drive the vehicle, that particular person is not available, means that is a policeman, or our cop is not available to ask him all the time. So why should we keep such things? Why cannot we have something automated system? So that's what the reason is, that then we decided to go for such patent. So basically, when we are addressing any kind of a problem, first of all, identify the basic fundamental of the problem. What is the problem in that? So basically, fundamental problem is lethargy of the drivers of two-wheelers to wear the helmet. That is, they feel more uncomfort, and whenever they are putting helmet onto their head and driving the vehicle, and they can't feel free or something. So that is one reason. Another one reason is that, so most of the people drink and drive, and that is nothing but a cause of accidents, and comes to some safety issues. And per year, maybe 5 to 6,000 people die due to the accidents on the roads. And why? How can we address this issue? So what is the basically? So this is what a problem, and to save the life of the human being. So what is the existing problem? Existing solution is helmet is there, but it's not optional for the driver. Means it is not a compulsion for the driver. Then we can't identify whether he has drunk it or something. So that is also another problem, and we can't go for it. There are separate systems available for this. Then the helmet, whenever you are going to drive something, the helmet doesn't need any power source actually currently. So that is what on a existing problems. Then why cannot we have something new into this element? We cannot be given a new features for this. Helmet is there. We are not going to file the patent for the helmet. But what is there are new features we are going to include. We will discuss this. Helmet is initially as an optional part for the driver. Why cannot we make it compulsion? We can make the compulsion by providing rules and regulation on the road safety or something. But that is also not all the times possible. So then there will be some safety system in the helmet itself. If you are going to drive, then vehicle will start. So that way we can plan it. That is the thing one way we can plan. Another one, whether we able to identify the drunken driver. If you could identify, avoid him for driving the vehicle. So that also we can do it. But when we are going to operate that electronic part, we don't have any power supply. So we can put up a power source onto this, and then that is solar powered operation, we can do it. Now look at the system which we propose. One of my student, Amit Dusani, just now I had on a call with him because we are having in a final stage of this patent, means we are reaching to the grant of it. So basically, whenever we are going to have an wearing the helmet, the problem is that whenever we wear this helmet, my vehicle doesn't know whether I weared this helmet or not. So why cannot we connect this helmet and vehicle by either wirelessly or maybe Bluetooth or any kind of connection? So when I wear the helmet, automatically that vehicle is going to identify. That is what in a smartness we put it. And that Bluetooth will now generate on a signal. It goes to the microcontroller, then operate the relay. This is one condition. Another one, the vehicle, driver will have a key, and both the conditions should satisfy. The person is having a key as well as a helmet. Both the things, he can take it together, and then ignition switch will start, and then vehicle will start. That is what basically sequence of operation we can do it. One more thing we included, that one more condition we need to include, because most of the driver is drinking and you are not, you don't want to allow him to drive it. So in that case, we can have one more condition, that sensor we can put it, which will detect the alcohol continuously. And that if person is going to use that helmet and vehicle, it will avoid to use if the driver is drunken. So that kind of conditions we can put, and we can have a patent onto this. To operate this, we need a power source. So for that purpose, we can mount solar panels on the helmet itself. It will, that is not huge power it needs to operate this microcontrollers, maybe 50 to 100 milliwatt power, and that can be generated from a very small solar power devices. Along with this, also we provided a few features on it. What are those features? If vehicle is going to move it to the right side or left side, you want to have an indication, we can have an LED array onto it. So it will indicate left, right indication, left indication, and also we can have a stop indication. So many things we can include it into, and we can provide more features onto that. This is what the one example as in a patent. Another one, so most of the, when you go to the doctor, and if a person is in having some critical condition, most of the time we need to provide in a blood for him. So whenever we are going to provide in a blood, so doctor takes in a blood bag from the refrigerator directly, and that temperature of the blood is approximately around about 8 degree or less than that, 8 degree. So that small lower temperature blood, if you're going to give it to the patient directly, so there is a problem with a patient that he may suffer from hypothermia and may have issues with some reactions he will get. So that is what a problem. So normally what they do as a doctor, they take this blood bag, they put into the hot water. That hot water is mostly more than 50 degree or 60 degree temperature. Then let that black will be there for 5 to 10 minutes, and then they take this bag, and then they will start injecting the blood into the patient. So in that case, what it happens, basically when you increase the temperature of the blood, so there is a limitation of the blood stability, or whatever the component of the blood, maybe an AHB, your white blood cells are there, red blood cells are there. As we increase the temperature, they will get damaged, and they will not be much more useful when it is going into the patient's body. So to avoid this, so when obviously you need in a lower temperature, and this is very easy solution we got it, but there will be one system we can propose it. So that why cannot we control and temperature perfectly onto this? That is what a blood warmer. We are going to warm the blood, which is cold and kept into the refrigerator. So what is this? Basically, we done it is a blood bag is there. So having a low temperature, then we can inject into the heat exchanger. This is what on a very crude level heat exchanger we designed in initial phase. Later we designed it in a very smart and a simple, easy device. So here there will be a heater. There will be a power supply for this. Then thermostat is there. It is going to monitor the temperature of coming outlet of the blood, and there will be, it will inject into the patient. We can have a separate power supply for all control and operations. So this is kind of in a system which doesn't exist currently. Why cannot we go for a new idea? This is what in a new idea where we can rely and you can go for filing the patent. Then we decided to file a patent. Later we decided this is entirely kept into the liquid. Liquid is going to heat it. So then we decided this liquid may get leaked and may disturb everything. To avoid that, we provided a dry kind of a heater, and that also will be much more helpful for this case. So this is what a typical patent, and whenever you are filing the patent, you need to provide all the component details, not in the names as we write into your journal publications, but we need to represent in terms of a number, and that numbering we need to provide into appropriate sequence. That is what these numbers. Here you can see in a heater part, then there will be a power supply, then this is a coil, and then blood inlet, blood outlet, all these details we need to provide. So this is what done with three to four of my students. One is Advait, another is a Kiran, and Shubham. All these three people are now currently working in different companies. Advait is having his own startup, and Shubham is also now currently in Germany for an MS. So then we'll now discuss about another problem. So we have discussed two problems. One is about smart helmet. Another is about blood warmer. Third one, we'll now look into the oxygenation device. So there will be conditions in the patient, condition of the patient. That is what a CICV condition they normally call. So CICV condition means can't incubate, can't ventilate condition. Patient may be in critical situation. In that case, what will happen that we need to pump the oxygen directly into his heart, or into the heart, and we need to continuously maintain that oxygen level into the body. So in that case, currently the problem is solved in this fashion. This is what a representation of the heart. So what are the bag you can see, that is nothing but a representation of heart. And this representation of the heart, this is a representation of heart. This is what an oxygen pipe, and this is what the valve through which we can pump the oxygen into this blood. You can just look at how this works. So when you close this, oxygen is going to fill into the nest bag. So that is what the manual way the people will operate this entire system. This is what another oxygen pipe and this all. So when you are going to pump the gas into this, so manually all the time we need to operate it, because most of the medical instruments are not still under development stage. And why cannot we have a kind of an automated system for this? And for this automation, we should know what is the level of oxygen available into that particular patient. And based on that, it will now decide the switching and amount of flow rate, and so many things we can decide it. So then we decided to develop one patent for this. So this is what a patient, and this patient will be monitored with his pulses, how many pulses currently he is having it, and also monitored with an SpO2 normally we call, that is what an oxygen monitoring system. And these two parameters will be taken as sensed into the patient, and based on that it will give it to the signal to the microcontroller, and there will be a decision maker, that is a touchpad is kept onto this. And this decision maker is now connected with this is a solenoid type of actuator device, so which will on and off the section. And this is a T section normally used for switching the on and off of the oxygen content into the human body. So this is what an oxygen cylinder And so normally you can't provide a 100% oxygen to the patient. Obviously, we need to mix it something. And that too also we need to maintain the pressure. If you provide in a high pressure also, it will create a problem. If you provide low pressure, oxygen will not go into the patient's heart, and that may create a problem. So in that case, we need to now also have a control on pressure of the gas going, or oxygen gas going into the patient's body. So this is what an entire idea is. New one, that's what is filed in a patent. So then another one is a manual scanner. Most of the time, whenever we want to have an accurate motion, so you may be knowing that lathe machine is having hardly 50 micron accuracy, manual accuracy is in 50 micron, and then if you are going for a vernier caliper, you will get an 100 micron accuracy. And if you're going for micro stages, that is a micro stages are screw gauge having a 10 micron accuracy, and you can't go beyond this time 10 micron. That is what the limitation. The reason for this limitation is there is a backlash into the system. There will be a friction into the system. We can't come out of this. That is what basically a problem. That's what we can't go for a very precise motion into this. And also there is a possibility key I want to have a screw gauge and I want to rotate it. So 0.5 mm pitch means when I'm going to rotate it completely, that 360-degree rotation. So my stage or nut will traverse within a 0.5 mm distance, and I can now give a marking on it. So that marking can be in a 10 micron, maybe something, and based on that I can now go on providing a precise motion for this. So whenever we are using such stages for micro application where I need an accuracy of a 1 micron or maybe a sub-micron level, so we find a difficulty into this. So to avoid this kind of a difficulty, there will be there should be a certain system which will really takes care of this, and it can have a lower accuracy. That is what I can get an accuracy around about 1 micron or less than that. So for that purpose, there are certain existing solutions. So people have the automated scanners available into the market, but they are too much costly. And that is what it is not affordable for maximum people to use for this. Then we decided to go for some new innovative idea for this. What is this idea is that basically it is on the same idea we pick up from the screw and nut type of arrangement. When we rotate this nut, there will be two screws are there. One is a right-handed screw and then another is a left-handed screw. So this right-handed screw and left-handed screw, both are manufactured, both are under one single rod, and there will be a conical shape. You can just look at this picture. There is a conical nut is provided and having a certain angle for it. And this angle is typically decided to get the motion to be amplified or de-amplified or kind of things. And then whenever you are going to rotate this right side or left side, so this cone, either it will come towards each other or they will go away from each other. And due to that, what will happen if I rest in a certain stage, this is what the stage, it will generate a perpendicular motion onto this. And that motion is decided by how much amount of these nuts are going to traverse towards each other, maybe away from it or towards each other. And now I can put this on spring-loaded kind of a system. I can put so that this what are the rollers mounted for the stage is completely attached continuously onto this. And later I can provide an appropriate friction-free surface like a roll-on coating or kind of things onto this, and I can get in a lesser and lesser zero kind of friction also. Whenever you are going to rotate this, and what is going to happen, what are the motion, output motion, depends on angle of this theta. If I provide this angle 45 degree exactly, so what will happen if I'm going to give a 1 mm distance here as an input, output also provide me 1 mm. If I provide an angle theta more than 45 degree, so if I'm going for a 1 mm, output may be 0.5 or less than 1 mm all the time. That is what it is called as a de-amplification. And if I provide on a larger angle or lesser angle, then I will get an amplification kind of things. That may depends on what amount of angle you're going to provide it. So now I can now have in a system where I can design this conical angle will now decide what will be the accuracy or what will be the motion, what will be the amplification of the motion for this. So that is what the basically idea, and based on that, we decided to use this as one simple device in all stages, micro stages or precision stages. So in this case, we decided to have only one single stage, which is spring loaded, and this motion is generated in vertical up and down direction. So whenever you are going to have a rotation of this, it will create one motion. And the amount, if I provide a angle for this is less than that, de-amplification, and if it is more than that, amplification will happen, kind of things will be done. Though based on this, we decided to have an XYZ stage. And that is what it is patented. This is one stage, this is another stage, and then there will be a Z stage also. Like this, we can provide XYZ manual stages for this. So then another one, the similar, this is what on a stage, and when you want to have a control of it. So it becomes difficult. We need to mount some sensors on it, and we need to control it. So that is what in the next part of it, next patent we filed onto this. But this, what are the mechanism we use in a flexural mechanism? Flexural means what it happens when you apply any force onto component, there will be a kind of a flexibility, means it will deform it. And why cannot we take an advantage of this deformation? And for that purpose, we decided to use beams or hinges to create a predetermined motion. We can design this mechanism so that there will be an XY motion or kind of things we can do it. But to get a more precise application or more accurate scanning, so actually we are using a position sensor. If you are going to use a sensor around about 50 nanometer or something, that sensor costs approximately more than 1 lakh or approximately up to 1 lakh rupees. And for one single sensor. And along with that, we are using a data acquisition system, then control system, so many things. And obviously that entire precision scanner mechanism itself will have a more cost it is involved. So why cannot we have a lower cost sensor? That is one thing. Another, why cannot we remove the sensor from my feedback itself? That also we can do it. So that is what basically idea. And feedback control with highly precise sensors is a current solution for this. So this is what a typical mechanism is used. Here it is optical encoder is used, which is having a Renisha optical encoder with a 50 nanometer accuracy. This 50 nanometer accuracy sensor approximately cost about 75 to 80,000 rupees, and this manufacturing of these beams, you can say it, which will give me a precise motion. So for actuation purpose, we use an actuator. That is what on a Y-scale actuator it is called. Y-scale actuators are simple. This is what in a coil, and there will be a magnet. So whenever you are going to assemble this and provide a current into the coil, what it happens, it will generate an opposing magnetic field. And due to that, it will generate a force. And one part of this coil is mounted on stage, and another part, that is magnet, mostly it is kept onto the fixed stage, and we can get in a traverse in one direction. So for this purpose, if you look into this Weiss coil, so whatever the motion happens is due to the bending of the beams. And in previous lecture, we saw there is an analytical model. We can model quite easily using this. We need not to worry. There will be no friction. There will not be backlash into this type of mechanism. So there is no problem in predicting the motion of this. That is what basically idea. And for that purpose, we can now have a model for it. So whenever you are going to control the entire this XY planar mechanism, what we have on a XY planar mechanism here, then we can have one position sensor here, another position sensor here. And so these are the two optical encoders used and given into the feedback. This is my reference signal. and control system will be actuated. So this is basically, this cost you can't avoid it. This cost we can't avoid it. If you could able to remove this and we go for a lower cost sensors, we can easily reduce the cost of this entire scanning mechanisms. For that purpose, what we decided to go into the depth of how this actuator works. This actuator itself is working in both the dual. It is working as an actuator as well as a sensor. How it is going to happen when you look into this actuator, and if you look into the components of actuator, there may be a property like a resistance of the coil, maybe a inductance, and these properties. And what are the voltage you're going to apply across this coil will be divided into three components. Voltage across the vice coil actuator. One component is in voltage drop across inductance, drop across resistance, and drop due to the velocity, relative velocity of your magnet and coil part. And that alpha is nothing but a motor constant. That motor constant is nothing but a connection between your electrical system and mechanical system. In electrical system, we provide a current, and mechanical system we convert into the force. So what is the relation between this? That is what it is alpha decides, and that is what connected with your what are the magnet flux and what are the length of the entire coil. These two parameters plays an important role. So here it is only one single parameter you can observe, that is what in a dx by dt, that's the velocity of it. And if you separate this and we keep all the components and all the terms on the right side of this, and if you integrate it, you will get an equation, and that equation is nothing but going to tell us an position of my coil relative to the magnet. So that is what you want to do. Actually, when you look into this equation, you can just observe there is a voltage is there is a current is there is a resistance is there, inductance. In resistance and inductance are constant property, that doesn't change it. But only change is going to happen, that is how much amount of voltage drop is there, how much amount of current drop is there. If you could able to monitor this voltage and current precisely, maybe in micro amperes and micro volts or somewhere, so in that case we can quite easily determine position continuously. That is what an online position you can do it. So then we decided to now remove this optical encoder by position estimator, and this position estimator needs a voltage measuring device and current measuring device. These RA and L is the constant, we need not to measure continuously. Only the changing is nothing but a current and voltage. And if you provide these two parameters into this equation, you will get in a position for maybe relative position between magnet and coil. And what are the rest is the position is due to the flexibility of your entire mechanism. And then we can provide into the loop, and you can develop your entire mechatronic system or control system based on this. So for that purpose, what we decided to go for XY mechanism. This is what on a double flexural parallelogram mechanism. So this middle stage is moving in this horizontal motion as well as vertical motion. This is XY stage, you can call it. And these two optical encoders are mounted on this particular mechanism. And this optical encoder is continuously giving to the microcontroller. And there will be a PC which is used to either control or monitor this entire stuff. And there are vice coil actuator which will generate the motion for this mechanism. So what are the current and voltage going into the coil? This is what in a white current and voltage measuring devices. So this current voltage measuring devices again generate voltage in terms of an analog signal, and then that can be given to the analog to digital converter into the D space. And this is what a linear current amplifier which will amplify the signal coming from the microcontroller. Maybe typically gain is 10:1 as well as 2:2 as a linear current amplifier gain, and then we need a power supply. So when we connect this, so actually what it happens, we can later, for initial purpose only, this optical encoder can be used. And later we can remove this optical encoder, and the entire stuff will work through this current and voltage monitoring system. And this will work like a position estimator for this. And this is what a new way of thought process, which it will avoid the entire use of optical encoder from the loop, and later it is used only for validation purpose, because we don't know how much current what will be in a position. So for initial purpose only, for test purpose only, we can use an optical encoder. So this is what a typical circuit in initial stage we designed it. And this circuit itself is our entire system circuit, and this entire system is nothing but a new idea, and that is what we filed in a patent for it. So this is what in a practical system. This is what in a we later we tested experimentally what will be the output and kind of things. And we observed that for a 500 micron position, we get in a somewhere 5 micron accuracy or something. So that is the way you can get in this sensorless operation, because we are not directly using in a position sensor for this. So that is what it is called as a sensorless operation. And then we can have an XY position and circular motion. Also, you can have any kind of an motion for this, and so many things we can do it. So मी परत बोलतो खाली तिचं अडकवलेस. Then this is what the way you can have an XY positioning and all these things. This is what on a one position and accuracies we are getting 5 micron. If you tune up more in more detail, we can get in a more and more accurate kind of a positioning. That is what on a 2D XY scanner. So for this purpose, we filed an Indian patent also and US patent also. And one of our students, Zahamre, was working in Purdue University, Indianapolis, and then we filed in collaboration with Purdue University at this quarter. So these are the people working that Dr. Sharad Mulik was a major contributor into this. Then Rishikesh was there. Then Mahesh Shawade was there. And this Ali Razban is from US, Purdue University. Was supported this to work in both the places, like in India as well as in US. So then last case study I will discuss, and then we'll move towards what the way we can file the patent. So last case study is nothing but my PhD problem. I put it into hardly 2-3 slides for this. So idea behind this problem was that there is a stereolithography system currently exists. And that stereolithography system is scanning the laser in X and Y direction and curing the part that liquid level liquid is converted into solidification. So whenever we are going to convert liquid to solid using a laser beam, so what are the size of the spot on which it is used? Or I can say if I am having a very small interaction between liquid polymer and laser spot, I'll get a very small features into the stereolithography or any 3D microfabrications kind of things. So if you keep this interaction very small and scan it with more accuracy, you will get a more and more accurate kind of a component. So that's what currently limited accuracies maybe in a 50 to 60 micron or 100 microns. Then it has an also limited speed because we want a more accuracy. That's what we go for a very small speed, that is a 2 mm per second. And also sometimes it is in a size of micro fabrication is a 5 mm, or that is what another limitation. And to break up this limitation, we decided to go for a system. So this is what a galvanomirror system is, an optical system, optical beam delivery system, that which will take on a laser beam, tune this laser beam, make it focus it and hit to the resin mat. Another one is a mechanism which will create an XY motion for this. In this XY motion, what it happens, this galvanomirrors are typically used, but whenever you put up a lens onto this, that spot characteristics, it changes. We'll just revise this different scanning mechanisms for this. So basically, accuracy is nothing but due to two parts of it. One is an optical system, it is used for it. Another one is a scanning mechanism. What is the accuracy of the scanning mechanism? Both will go hand in hand, and they will decide what will be the accuracy of my fabricated micro component. So for that purpose, we first of all decided to identify what are the currently people use this scanning mechanisms. So first is scanning mechanism they mostly use as a post-objective scanning mechanism. In this post-objective or galvanomirror scanning, so lens is kept here. That is what it is typically called as an objective, and there is a mirror. This is another mirror. So when you look into this mirror, when there is a rotational symbol is given, when you rotate this mirror, my scanning on the resin surface will be y direction something. And if I rotate this M2 mirror, it will have an X position scanning. So whenever you are going to use this system, there is a lens and then it will start focusing and it will exactly focus at this point. But as it is going to scan, it will create a spherical focal surface. It is not creating a horizontal focal surface. If my resin is spherical, I can't keep this my resin continuously spherical. So for that purpose, what is to be done? So my scanning means my spot has to move from focus to then a certain more distance. And then that is nothing but a defocusing. And that is going to increase the spot size. And also it is going to distort the spot also. So that is what a limitation for this galvanometer scanner. And then people have decided, why cannot we go for another one which will avoid this problem? And then this is, they move this lens from this position to after the scanner. That is what in a pre-objective scanning. This is a post-objective, this is an objective, and then post of this objective, the scanning is there. Here it is a pre-objective, this is the objective, and before that, scanning is done. So that's what it is called as a pre-objective. But in this case, you can observe there is one axis that is the lens axis. Another one is a beam axis. It is continuously changing. It is not maintaining that axial alignment between optical axis of the lens and the laser beam axis. Due to that, what it happens, there will be a distortion due to this angular misalignment. Spot size will be completely distorted. And spot characteristics continuously varies during the scan. That is what a limitation comes out to be here. To avoid this limitation, there should be a certain system which will maintain these two axes during the entire scanning. That is also one more requirement is there. So then another one, when we are going to have a problem, so another one is people have thought, why cannot we keep in a lens and resin surface, and will now only move the lens. I will not have any optical scanner before it, but only lens I'm going to move in X and Y direction. That also gives me scanning. And another one scanning is in a photoreactor tank scanning. These pictures have clipped it. Maybe this picture should be here and this picture should be here. So that is what this picture shows an off-axis scanning, and this shows in a photoreactor tank scanning. In photoreactor tank, that resin surface is XY direction moved. And due to this scanning, there will be this is nothing but a liquid you're going to scan. And due to this liquid scanning, what it happens, there will be a waves it will generate onto the particular tank. And due to this waves, there will be a limited accuracy you can get and very microstructure you can manufacture. And that is what also one disadvantage you can get is there will be a limitation on the fabrication speed. So these are the difficulties people face in different scanning systems. Then we decided, we came up with some reasoning, basic requirement of optical scanning for stereolithography. So we need an uniform spot characteristics. I don't want to change the spot during scanning anywhere on the XY plane. So that is what basically a limitation. Constant spot size should be there, uniform intensity into the profile will be there during entire range of the scanning. So that is possible only when optical axis of the lens and laser beam axis exactly match during the scanning, and you maintain the alignment over the entire scan range of it. So that is only possible, and we don't have any idea or any scanning mechanism to maintain this axis. Then another one, to avoid this wavy structure, our resin tank should be stationary. It should not move at, and so that there will not be waves on the surface on the stage, and it will create a problem for this. So then we decided to go for this new kind of a scanner. You can just look at this particular picture. So when you are going to scan it this way, So that is a laser beam axis and lens axis, though both are maintaining the one single axis. And obviously during this one direction motion, you need not have any difficulty in maintaining both the axes. And obviously I can now tune up focus distance and I can get exact spot here. And that spot characteristic is not going to change during the scanning. And then another direction, the same thing you can do it. So I can now traverse this all the three, that mirror 1, mirror 2, and lens in other direction. And whenever you are scanning, make sure that axis of scanning should be in the direction of the laser beam. That is also most important. This is what an idea. And most of the time, idea cannot be directly patented. Idea should be converted into some physical device and then can be patented. It should have some commercial utility, and so that is what then it is a requirement. We'll discuss that part in later part of our presentation. So this now have a different idea, completely different from whatever the things we have seen. It is not the same as nothing is copied or nothing is the same in between previous scanning mechanism and this proposed scanning mechanism. Then obviously it is now, this is what an idea, it should be verified within a certain theoretical concept as well as an experimental concept. Then we decided to develop a mathematical model, which you previous lecture you have seen. We developed a mathematical model for optical scanning as well as experimental setup for this. And then we compared both this. So whenever you are scanning from -4 mm to +4 mm, your spot is not going to change. But in other cases, you can observe there is a large change in the spot on its characteristics. So this is what basically we got a major disadvantage of it, advantage of it. So we can go for this type of a scanner, and which will maintain the spot or spot size from one point to another point constant. It doesn't changes. Also, it gives a constant peak intensity into this. So that is then we need to now develop an entire optical system. Around that, we need to develop mechatronics for this. That is what it is called as an optical system connected with a mechatronic system, that is optomechatronic system. What are the mechanism I showed you? That is a flexural mechanism. Also use the same sort of mechanism into this, so which will give a better accuracy, maybe around about submicron or somewhere 10-15 nanometer accuracy we can get it. So for that purpose, we have two Y-square motors and then D2A converter, current amplifiers, then there will be D-space, then optical encoder 1 and 2, both direction motion sensing, then Z direction optical encoder. Then there will be a resin watt kind of system. Then layer thickness we can adjust by using a Z stage. Then there will be a switching of the laser on and off. That is what it is used, acoust-optical modulator. This acoust-optical modulator can give me a very fast switching. Why we need a fast switching? Whenever you may be knowing that we are using some cameras in previous days. So these are mechanical cameras. When we provide a button for it, what it happens, it will that shutter will on and off it. So that is an entirely mechanical system, and that mechanical system has a limitation. It can switch laser or light on and off within a hardly few milliseconds of it. But if your scanning speed, you want to increase it very high, so that speed will not be, whatever the switching time is not sufficient. So for that purpose, we need a very high speed switching. That is what it is called as an acoust-optical modulator use. So it is an optical system, and it will create an automatic grating whenever you provide a mechanical pulse for it, and based on that, it will divert the beams into two beams and kind of things it will be used. That is what an acoust-optical modulator use. And this is now entirely one single system which will manufacture 3D components. And this is what in a typical demonstration I can show you for this system. Now, this is what on a laser beam. This is what on a switch, optical switch. You can see it. These are the mirrors, two mirrors for an alignment purpose. And this is what on a pinhole through which that laser beam is going to pass, because you will get 2-3 beams. Out of that, we need to adjust for a high intensity beam, and that only you need to pass it. And then there is a scanning mechanism. It is a precise scanning. Here you can see in wise coil motors. There is an optical encoder. Then these beams are for an high precise scanning purpose. And here you can observe it is an automatically switching the laser beam on and off. This is what on a stage on which you can manufacture 3D components. And here it is an entire tank, because it needs a very small liquid, and we should have a smaller liquid tank also. Then there is a jet stage. Jet stage is also spring-loaded jet stage. We use it, and then we have a GUI for controlling this entire system. This is what an entire GUI. And whatever the controllers, back-end controller is nothing but an electronics devices. So these are the optical, that is a current amplifier, optical encoder. This is what an RF switch for switching on and off the entire system. So this is what again patented, and we manufactured few micro component, that is a micro pyramid. Base of this micro pyramid is approximately around about 1 mm, and top of this is 200 micron. Typically, I will give an idea that 100 micron means our hair diameter. We can keep hardly 2 hairs at the top of it. That is, diameter of the hair is 100 micron. So these are the micro cones, and downward circle diameter of the cone is around about 300 micron, and top is very less than maybe 50 micron or something. So then few more scaffold, then micro tanks, then micro channels, then so many other micro structures, axis symmetric structures, overhanging structures, micro voxels, so even micro pins. These pins having you can just imagine here it is this kind of a pin as again designed using controlling the laser intensity hitting to this. And that is what. So these are the people involved in doing this entire work in IIT Bombay. That is Prasanna Gandhi was there. Then Professor Kiran Bhole, then Amit Patak, Rahul Ramtekar, an entire team of this Suman Mashrawala Advanced Microengineering Lab, as well as supporter for this is Raj Mashrawala. He's an alumnus and owner of TIPCO software company. Many more people are there involved in developing this. Only one single person can't do all this stuff. Then now we'll look at it. These are the few case studies we discussed. And now we'll look at by step, what does that patent means. We got in a new way of thought process. These few case studies will tell you what is the way we can go for new ideas. What is the way we can convert existing system into new way of thought process. Appa, direct pani de to ke glass. So we'll now look at what does that patent means. Patent is nothing but a protection granted by the national government for an invention. So what is protection? What kind of a protection they provide? They provide a protection for your ideas. So that is what an intellectual property they call it. Similarly, way if you go and purchase a land, so procedure is that we'll go into the office at Howell office, and then we'll show them a drawing. This is what north, south direction, all the drawing we provide to that person, and based on that, he will now given a authority to you people to operate or use that particular land, and he will charge for it, and maybe some amount he's going to charge, maybe 50,000, or depends on the size of it. And that is what nothing but a property you have it. That is a physical property. I can show you. I can tell you that it's physical property. You got it. So similarly, if you want to have some intellectual property, like I have some new designs into my life, I want to have some new products, but I want this product should not be copied by anyone. So you individual, you can't control anything. So that's what government taken some initiative to for filing the patent. And that's what they have decided to have some law for it. That is what in a patent protection law we can say. This is nothing but a patent is a protection granted by any government, maybe not only Indian government, any outside government, out of India also you can file. So many places you can do it. So this protection excludes others for making and using and selling your invention for next 20 years of period. But in India, whatever patent you file it, from that day for next 20 year, you have an authority. After 20 year, you don't have any authority about your device. So keep in mind, because our life is short enough. So within these 20 years, you can make it a product, you can convert into product and you can sell it to people. Many drug companies and university researchers seek the protection or to cover the research development costs for the patents related to the specific genes, proteins, laboratory techniques, drugs. So these are the research activity. एक वाजते मला चालू करून दे ना तिकडे एक तास एकच्या आधी मला संपणार नाही
मला योगीराजचा नंबर देतात कारण खालच्या रूमची चार्जेस नाही का
म्हणून मी लवकर येऊन बघतो
काम चालू करायचं एक नंतर ना
एक नंतर. So here we can have drug companies and university researchers who want protection for their work. So for that purpose, so there is a certain law for it. They want to commercialize it. For that purpose, we need to have the support of the government. So there, in order to patents to be issued to the granting agencies such as patent office, they need to useful. They will go through your document, and based on that, they will decide whether it is to be awarded patent or some modifications are to be suggested or rejected, or somebody's copies that whole stuff they will identify, and based on that they will process it. So there will be a patents. Means patent is not only intellectual property, can be of anything. Like in a patents, it will be in terms of a patent, maybe in terms of copyrights, maybe in terms of trademarks or trade secrets. So it is an intellectual property. Is nothing but a creation of human mind. It is not a physical property or something. So which is protected by any government. Not I will say it is only U.S. government, maybe a certain law in fashion similar to the real property, piece of land or anything. And intellectual property includes these patents, copyrights. Under this copyrights, music is one of the copyright. Another is a book is another copyright. Trademarks means you're going to create a brand for it, brand of the company. That is what comes under the trademark. Trade secrets means business secrets. So that also can be patented. So that is what basically a patent means. So now what is the basically history for this? In 1790, patent that US had started their patenting act at first. So they have decided, why cannot we provide a protection for the intellectual stuffs? And then amendment have done from 1790 to so many till the date they have done so many amendments for this. Then, but in India they have started this patenting in 1970, and they have done a few more amendment, 3 different amendment in 99, 2002, 2008, and these amendments are nothing but an addition of it. So which will give a more protection or some more features about as per development or progress of this entire country, it will be decided. Then we'll just look at it. Is going to provide you a legal protection which gives an inventor to the right to exclude others for performing certain activity into the country of issuance. Country of issuance means this patent is mostly given from the country or government. It will not be globally accepted by all the countries. So we have more than 150 countries. So they may don't accept it. I can provide a patent in this country only. Means what are your ideas will be protected by a region wise, not with this worldwide. And this gives a monopoly for using this your idea for certain years, okay, certain years. And whatever the disclosure made into your compound, whatever your document will be kept into the government website or government documentation, so that everybody will come to know, yeah, this is what it is protected, I can't copy it. And this does not give an inventor the right to make or sell the patented invention. Okay, so there will be most of the time people think what will be the difference between what are the scholar publications and what is the patent. See, patent means which gives in you something new meaning for yourself, because you are going to have something innovative, you will be known for it. So inventor means you are having something new thought process you are given. So that is what it is called as an inventorship law. It is a matter of law itself. But in publication, there is no as such law defined for this. So publication means we have some system and you have a small modifications, and you're going to have a research, or you are having some ideas, and you are going to do some experiment, and based on those experiments, you are going to present in a document. That is what it is called as a publication. And here, mostly this author, we can put 1, 2, 3, 4, or many also. There is no issue in it. Some practical work should be done onto this. Then and then we can have a result, and those results will be presented into the paper. Then future ideas can interfere, and previous ideas can be used, and we can go on doing the same type of work, and we can present the work as a scholarly publication. But in patent, it is in a constructive reduction to the practice. Means you want to convert your idea into the product, and product is to be converted into market. Basically, intention is to provide commercial product, generate a commercial product out of patent. But in publication, this doesn't happen. And which is patent is nothing but it is a kind of I can say it is an asset for you, which will give you the money in future. So that is what the disclosure of the ideas for many future uses as possible to strengthen the patent also it is possible. So what can be patented? Most important. So publications, we can do an experiment, re-experiment it, we can publish it, you can provide more and more stuff. But in patent, this doesn't happen. Patent can be done only once for particular idea or particular product. That patent is done at only once. It can't be twice, or cannot be go for multiple such things. So basically, this patent can be patented. Anything which you want to patent should have these conditions. It should be new or novel. Novel means nobody has done it previously. That is what it is. A novelty should have. And next important point, these three part all the time we need to check it. The second point is in a usefulness. There should be a concrete or tangible product it should convert, and it should convert into the money also in future. That is what it is called as a commercial. It should have some commercial aspect for it, and that is what it is called as a utility, you can say, or usefulness of that particular idea, invention, and your product. Then next one is it should be non-obvious. Obvious and non-obvious. Obvious means anybody can do it. This is obvious. I can do this activity or that activity. If somebody is doing some athletic activity, it is completely non-obvious to any other person, or some other idea which is not thought by any other person. That is what it is called as a non-obvious. And obvious means is it obvious to Fostia? That is what a person having an ordinary skill in the art and cannot be found in a single or reasonable combination of the patents. Means there, whenever you file in a patent, make sure that it is what are the idea you are going to present it. It should not be there by any other mean also, and that is also to be avoided. So idea cannot be patented. Law of nature cannot be patented, or any scientific principle also cannot be patented. Only idea it will not go. Means I will, what are the stereolithography part I told you. So there are 2-3 mirrors and then lenses there, and that much only. If I'm going to file the patent, they will straight away reject it because this is a simple idea. So we need to convert that idea into product. We need to provide in a mechanical, mechatronics, or any chemical druggery system around it, and that is what it is expected. And if you convert that into the product, then it will be filed as a patent. So patent starts with an idea. There is no, I will not say ki idea is not there into the patent. Patent starts with a typical idea, which is innovative one. And that idea to be converted into certain product, commercial product or something. And then that can be filed in a patent. So whenever you are filing in a patent, we need to follow on a certain procedure. What are, see, when we are sitting at in one place and I want to file in a patent. So this is not going to happen. First of all, you need to identify the problems currently people are facing. So those problems may be from your day-to-day life, like in our corona condition is there. We people are now facing many problems. We need to have a mask wear, we need to have sanitization. So many things are there. So these are the day-to-day problems comes into this. There are certain industrial issues. Industrial part is there. In that industrial part, so industry works for certain product development or processes there. In that case, those you can identify certain issues out of it. You need to go for some innovative idea, then you need to go for. So that is what, first of all, you need to identify the problems. There will be a certain environmental issues. All these problems bring it and take up one single problem, then move forward. So that is what the next part is. What are the different problems people have solved? What is the way they have handled this issue? Corona problem. Just take an example of corona issues. In this corona, when you want to protect ourselves, we use a mask. This is what in one way people have used. Mask is previously used by most of the doctors, so I can't go as in a mask as in a patent. Okay, so if I have something innovative into the mask, then I can go for a patenting. So to solve this, we can look into the different existing methods, tools people are using it. Then you need to identify what are the scientific tools and methods available for it. So now, then we'll conceive a few ideas. Maybe idea number 1, 2, 3, maybe 10 ideas or kind of things. So 10 ideas you came up with. So these are new one, we think it. But so my experience is that when we started filing in the first patent, I may really collected more than 100 patents altogether. And then whichever idea I'm thinking, okay, I have to go for this as a patent. This is a new idea, I feel. But whenever I put this idea into the net and search it, somebody has done it. So that's what we should know. What is current status of the technology? So that's what we need to concise all the ideas. Then you need to start the searching into the patent database. Once you search into the patent database, you will come to know. So first idea is already done by somebody else. Then second is also done by somebody else. Third is also done by somebody else. Then fourth, okay, nobody has done it. Now take up this idea and then create a documentation for this. And then this documentation is to be handed over to the patent office. And then patent office will now create a further procedure for filing the or giving a protection for you people for the patent. So whenever you are going to have a requirement, what will be the patent to be filed? What are the requirements of patentability? So first requirement, you can't say, okay, I got these results and I want to file the patent. You can't go for such things. What is the way? It should have a certain usefulness. It should be claimed as an invention, useful, or certain functions should be there. So that is what a utility patent. I can tell you one simple example in this case. Usefulness means what? So most of the people are driving two-wheeler, and whenever they drive the two-wheeler, so two person sits, driver and behind this. So we face some difficulty, and that's what we came up with a new patent, that is a footrest kind of a patent. So once it was happened in one accident, and due to that, it was accident was only the reason that that person want to open that footrest, and that is what he has done. He opened that footrest by hand, and due to that, that entire vehicle got unbalanced and they got an accident. Then idea comes, why cannot we have some automated system for this? Then we decided to go for that. Then we decided to have some switch on to the back seat. That switch will get automatically on, and that is connected to your footrest, and there will be a springing mechanism which will open the automatically footrest kind of things. So that is, now I can provide this vehicle, this one accessory for this vehicle, and that accessory can be used, and that is nothing but a patented. So I can't have a complete vehicle as a patent, single patent. I can have multiple ideas or multiple products into the vehicle, and I can go for multiple patents into this. So that is what then you need to identify usefulness, and it may avoid an accident. It may improve the productivity of the system. It may be making you easy of use. That kind of things. That comes under the usefulness or utility of the system. A machine must work according to its intended purpose, and maybe a chemical must exist, an activity or some use also we can have it. So next comes is something new should be there. Nobody has done it. That is what it is called as a novelty. And third one is a non-obviousness or ingenuity. Means it should be something new. It should not be done as it is. So that is what the way you can have a patentability. Whenever we are going for a patent, so there will be three types of patent comes into defined by the governments. So first is a utility patent, next is a design patent, and third is a plant patents. In design patent or utility patent, we just look at the patent. So issued by any process, machine, or article of the manufacturer, composition of matters, useful improvement, and kind of things. All these are includes into the utility. It has a certain utility. That's what it is. Name is given as a utility. It defines as a product. Okay, and that's what it is called as a utility patent. So example is, I can show you that as blood warmer. Well, all the patents we filed as a utility patents. We never gone for a design patent. In this design patent, it should be a new one. It should have some original stuff. We never used it previously. That is what that is expected. Then there may be an ornamental design for an article of manufacturer, or any kind of an eyeglasses, some new design. It's not normal. If you want to improve any aesthetic part, that is also comes into the patent. And third one is in a patent, that is a patent, plant patent. Plant patent means you can hybrid it and you can create new one, reproduce it. Okay, that is what in a plant patents. So when we look at the patent and patent family, under this patent family means what it happens, it is a group of patent documents from different countries that protect the same invention. Now, I filed in a patent into the Indian context or Indian environment. Same idea will be there for out of the India also. So obviously that idea also to be protected, and this idea is also to be protected. So that comes under a patent family. And that is there will be a defines. It defines in a geographical scope of the patent protection. We'll discuss this in detail under PCT part of it, and it has a usefulness for locating alternate language version of the patent document. And patent coverage only applies within the country that grants a patent, so that inventor must file a patent application in every country for the protection wherever he wanted. That is what basically, because government has a different rule, each country has different rules. Obviously, we need to follow those rules, and based on that, we can have on a filing your protection in other countries. So when we are going to file a patent, we need to create a document, and that document tells you about your invention, and that's what it has. In only 3 stages it comes. So it comes into the cover page, under which can say key, I want to file the patent. That's in a simple letter. It is given from the inventor to the patent office. So next part is called as a disclosure or description of your or complete specification of your patent. So this gives in a clear, this should be written in clear and concise description of your invention, usefulness of your all the drawings, and it should must be so clear that if somebody want to manufacture, he can completely make it quite easily. So that kind of specification and each and every stuff should be included into this. So that is what basically idea behind this description. And what are the content of this? It is nothing but a title of invention should be there. It is a precise, it should not be very long title out, which will define, because whenever we are searching the patent, first we are going to search the title. And that title should be somewhat unique. It should be something different. It should not be repeated or something. Then statement of the patent history means what is the field, what is the work it has done it. What that is what in a history you can say. And what is the field of the invention, then background, and then summary of the inventions in the, what are the invention in broader terms, what is the idea, and that is what we can say it is an abstract also. Then we need to provide appropriate drawings. Then we need to give a description of the drawings and detailed description of the entire invention. So that comes up into the description. And most important is in a claims. Claims means what ideas or what kind of a design you want to provide in a protection. Means that is provides a boundary for your protection. Boundaries of your patent protection. Means if I'm going to file the patent for blood warmer, I will say there is a blood warmer. There is a mechanism consists of this, and working of this. This consists of this all component is one claim. Another one working of this entire stuff in appropriate sequence. Then it is another claim. Likewise, you can go on at least 3 to 4 claims. Don't go for more claims. Whenever you are going to write in a claims, make sure that it is going to cover broader perspective. It should not be in a smaller perspective. Just one example I can tell you. Few months back, one of my student came with me and asked me the idea that whenever we go for a urine, so there isn't a problem that our automatic flushing system is there, but most of the time this automatic flushing system doesn't work, and maybe some electronics issues will be there, and it needs a separate power supply or something. Then he came up with some new idea that he want to file a patent within a mechanical system entirely. Mechanical system is that if a person is going to stand in front of that urinate box, then automatically water should deliver kind of things. He has created a mechanism with servo mechanism and something complicated mechanism he created. Then we searched onto the internet, somebody has done it. No, nobody has done it. Then we decided to file a patent. That is what when, but he want to restrict his patent within that particular purview of the urinate or cleaning purpose. Then I decided, why you're restricting for this? Why cannot, what this idea can be used for any other purpose also. I can use it for washing the hands. I can use for controlling the amount of liquid in anywhere. And then we provided in a broader perspective for this, and which gives that patent can be now applicable for so many places, not only one single place. That is what the expectation. We need to define your boundaries of the patent, where it can be applied. And written statement of this broader will now decide whether it is to be protected or what is it is coming under that particular purview or not. So why to write? We need to give a more effort onto the claims than any other part of this. The reason for this, if somebody has copied your material and you want a protection, if it is not mentioned into your claims, so if you are mentioning in this your entire description, that doesn't matter. If it is not mentioned in the claims, you don't have any rights to ask him to stop his manufacturing or pay for that patent. So that's what claims are most important. When you're defining the claims, give an appropriate broader perspective. Think in all aspects. So where I can apply this idea, and based on that, I need a protection. So that is what claims you can define, and claim should not be in a very large one, hardly 3 to 4 lines of the statements, and it should not be like an entire paragraph or kind of things. So whenever we are going to search the patent, so when you want to file in a patent, you need to search it. So what are the different codes for this? That are the identification of the data, that is agreed number for the identification of the data. So patent number is one, then document type is one, then application number is another one, patent filing date. Patent filing date is an important into this. So there will be if you are going to file in a patent earlier, that is what it is, gives you more protection. If you have come up with an idea, that's what government has given 2 options for filing the patent. One is you can provisional filing, and another one is a complete specification. In provisional filing, what is to be done? You can provide a complete specifications within next 12 months of period. Before that also you can file in a patent. There is no harm in it. So date of patent, publication, issue, international, patent classification, domestic, whether it is a domestic or national specific classifications, what is its title, abstract or claims, then list of the art documents or pictures, or what are the names of inventors, applicants, grantees, holders, assignees, and owners. All this comes into this. So when we are going to have patents, these are the few international patents offices. One is Worldwide Intellectual Property Office. So that is what it is called as a WIPO. So then there will be a US patent office, that is USPTO. Then if you click onto this, there is an appropriate link for these offices. I'm going to share this PPTs. Then European office, they protect for a particular bunch of the countries. This worldwide means it is going to control over the entire world. Then Canadian patents will be for a Canadian part of geographical part of Canada, kind of things. And along with this, Canada may have some policies with other countries, and based on that, they will provide a protection in other countries also. That also is possible. For Indian Patent Office, there are 4 places. Offices are there. There is a Mumbai Patent Office, controls in Maharashtra, Gujarat, Madhya Pradesh, Goa, and Chhattisgarh, part of it. Chennai Patent Office will be in Andhra Pradesh, Karnataka, Tamil Nadu, Kerala, Pondicherry, and all the places. Then Delhi Patent Office is north part of the country, that is Haryana, Himachal Pradesh, Jammu Kashmir, Punjab, Uttaranchal, Chandigarh, all these places. And Kolkata is rest, that is east part of the entire country will be controlled under Kolkata. So why should we do the patent search? Whenever we do in a patent process, a patent is nothing but an expensive process. In India, it may need as a government fees, you may be going to pay up to 9,000 rupees to file a patent. It is nothing but it is a costly affair. That's what. Whenever we are filing a patent, your money should not go waste. So for that purpose, you need to have a strong reason to get approval of this patent. So that's what you need to have in a search. And also, search will help us to give you better and strong patent application. And you can have a new idea you can come up with. If you go on searching more and more, you will come up with more ideas, and that is what basically reason. So whenever you are searching the patent, so there should be whenever you are searching the patent onto the website, I'm going to give the list of the few patent website search. So to be most effective in your search for the patent, you must determine how your invention works, not how you will use your invention. Means if I'm going to use a blood warmer, so I could not put it in a blood warmer as a name for it. Rather than I will say automated blood control, so blood temperature control system, temperature control of blood, like these keywords we need to identify. Okay, so for that purpose, you need to make a list of entire words which will describe your idea. Okay, words, you need to define certain words or identify words and make a list of it. And now start searching these words by one. Maybe you can provide in a Boolean logic, like this and this word, this or this word, or this, so many words like this. You can provide in a Boolean kind of searches. And now you can search these terms into the class, subclass of related atoms. Then first of all, before that, ask yourself, what does the invention do? What is the basically idea? What is the idea, or what is its utility? What is the end result, or anything unique, special, and unexpected you're going to do it? What is it made of? Maybe in a method, maybe of a material, or maybe of a new fabrication or process technology, or what it is used for it. These are the questions you need to ask. And keep a track of useful and non-useful patents by patent numbers to avoid duplication of the work. So these are the most important searching tips you need to maintain whenever you are searching the patents. So when you are searching the patent, there is an appropriate process for it. So first of all, purpose of the search, you need to identify what is my purpose to search the patent. And if you're going to search it, this is what Google patents or entire internet is a huge amount of information. All that information you can't read it, and you can't get all the things. So that's what you need to identify. What is exactly you want it, and based on that, you need to decide in a scope. Then once you decide the scope, then select keywords and prepare in a search qualities. And you can now provide in a combination of these words and go on extracting the data. Once you extracted the data, you will get so much of the patents, and then you need to segregate it. So this is useful, this is not useful, useful, not useful. Then again categorize it. Maybe some patents are talking about the process, some patents are talking about your new method or kind of things. You categorize this. Once you entire categories are decided, then you can now decide whether your patent somewhere matches with this or not. Then you can go on. So here there are free online resources. There is a patent scope. WIPO is giving you patent search scope. Then lens. Here it is in a WIPO. You will get an all PCT applications that into this. Then Google Patents is also there. All the places you need to search your ideas, and based on that only you can go ahead with this. So this is what a typical process for filing the patent in Indian context. So you first of all start here, means you have completed your specifications and everything. So this is what a provisional specification, or you can provide it. Once you provide in a provisional specification, you can file your complete specification within 12 months of period. Or else you can provide in a complete specification at start itself. There is no problem. And your publication will be there the next. Nowadays, that time is hardly 5 to 6 days. It has reduced. So previously, it was taking more than 2-3 months period. Now they have increased the speed of publication. So publication is nothing but in a second stage into your patent, and this is what in the last stage where you're getting grant of it. Keep in mind, publication doesn't mean that you are the owner of the patent. So then now the office is going to provide certain, means they are going to discuss it, whether that whatever the document they have got it, wherever it matches, they will compare it. Even they do so many examinations, so many things they do it, and they will provide you first examination report. And this first examination report, we need to provide a response for it. You need to, they may object, like your entire document is not patentable. There is no idea as a patenting idea or anything. And then it will go for reply for the examination. Based on that, you need to reply the examination. What are the questions they have asked? We need to reply for it. Sometimes they may say, okay, this idea is there in this patent, just give me a more explanation. That also you need to do it. Then after that, it goes to rejection or acceptance. So then based on this examination, they will decide whether what are the reply you are going to give. Based on that, they will decide whether it is to be accepted or it is to be rejected. And then you can deny the patent, or it will be granted for monopoly for 20 years. That is what the process will follow it. So this comes under Indian patent filing process. So there are different modes of filing patent application in foreign countries. So there are two modes which are, I know it, I'm going to present it. One is a Paris Convention, and which gives a protection of industrial properties, provides 12-month time to file the patent application in member countries, and they have a bunch of the country within that your protection is allowed. But in PCT, that is what in a patent cooperation treaty system, that is what it is a PCT, they say. PCT is the system which allows the applicant to file in a patent contracting states within 30 to 31 months priority date instead of 12 months. And we can go for preliminary examination based on this. So PCT is the international treaty, and it has more than 150 contracting countries come together, and they decided. So if somebody is having a new idea, we can provide support for them. That is what an idea behind this PCT. And as per Indian Patent Act, has amendment in the patent rules amended by rules, that is 2016, any PCT international application may be filed designated in India, and it shall deem to be an application. It is compulsory. You can go ahead directly for an international filing also and national filing also. So we need to just process that into PCT applications. So these are the PCT steps: filing the international application in receiving office, or it is a receiving office. Then international search by international search authorities, they do it. And then they will provide you international preliminary examination. And international preliminary examining authority will give you the one letter of entire examination. And based on that, you need to respond. And based on your response, they will decide whether it is to be granted or denied for the patent. So these are the few dates: are receiving office occurs an international filing date, date of receipt, so many things we need to go and to include, and we need to do it. International filing date is considered to be an actual filing date in the country designated in the request. That is what an advantage of PCT you can get it. So if I'm filing the patent in India today, okay, and I may be filing the patent after 6 months for an international, my protection will be there from this. If somebody has filed in a patent, whatever the information of yours, and later date of yours, you can straight away get support from government to protect your idea. If your filing date is previous, I mean, it's a later one, so you can't get any protection for this. So this is what a typical process. You can just go through this process. That is a PCT application. That provisional filing, you need to do it within 12 months. And then first filing in India, 6 weeks. PCT filing, you can go. Then foreign filing permit, 21 days it will take. Then it will search report they will do. So they will go on whether it is yes, no. And then finally comes to the final international phase. That is what it does. So in US also the same procedure is there. There is no much more difference in it. But so that is in search the United States Patent Search Trademark Office, then find it, then determine it, then file it, and then go for an online, because they support for automated systems. That is what in register e-filer, then determine all those things. We can do it. Then you can review the process, then participate in the process, then provide an appropriate grant for it. That is what it does. So this is what a typical Indian patent process. That is a filing in India was filed in complete provision. If it is a provisional, then allow for more 12 months. If it is a complete, then go for publishing for 8 months. And then we need to provide a requesting examination. Then within 24 months, you will get an examination report. Then decision 36, whether it is a granted or refusal based on your response. So then conventional countries, if you want to go for another country or something, so you need to go for here one more book comes onto this, that is what a foreign filing permit. So that will be for 21 days. Once you file the patent, for within 21 days, we need to put the same letter to the foreign filing permit and follow the same process. There is no issue in it. So most important in last statement, I can say there is an ideas cannot be protected. Invention can be, inventions are patentable. Already I told ideas means I have some idea and I want to file the patent. That is not anyway acceptable. You need to convert that idea into an appropriate product. That is what it is expected, and that is it is a expectation. So after filing the patent, what is to be done? That is also again a question mark. And we can develop your business proposal or model for your product, and you can start market search, get the money from the government or even banking, get the loan and start your business. And that is entire authority is given to you. Nobody's means if you have a patent, you can sell it to others also. There is no issue, difficulty into this. That is what the way you can do it. And there is one more patent for partnership. Is one program, and under this you can put your patent on USPTO site, and they will support you for a business development, or they will give a proper platform for market your patent. So there are a few problems which are, I feel it, I'm going to put in front of you. One is creating a model of the brain. And what does that model means? See, what are the information I'm storing into my brain? Okay. It is not increasing the size of the brain. It doesn't increasing the number of brain cells into my brain. But still it is storing more and more information. Like in our hard disk, if I fill up the hard disk 1 terabyte, then 2nd terabyte, then 3rd terabyte, likewise I can go on increasing the size of the hard disk. But our brain doesn't work on that fashion. It worked on mapping part of it. Mapping means it is going to have a curvature. If you have a data of 10 points you want to fit it, what do we do? You will fit the data within a simple equation, maybe in a straight line y is equal to mx plus c. In this y is equal to mx plus c, you're going to remembering only m and c, two parameters. Okay, and that is what it is called as an mx. That two parameters are nothing but telling you all the rest of the numbers. If you are going to provide few more numbers, what is going to happen? You are going to include few more data into this, and obviously you are going to modify this MNC. So, do you have any system which will store this entire information by just creating some algorithms or mathematical tool which will store those entire stuff into a single hard disk or kind of things? That is what in a brain up model to store the information, and that it only needs a processing power, and hardly maybe in some few numbers we need to store and continuously to be updated. And these updated number will be all the time, it is going to store more and more numbers. That is what the way you can define the model of the brain. Next is we know that pollution is the major issue in all the countries as well as all the cities into this. So is there any system which we can mount it at the end of the silencer which will break up this all poisonous gases? So we can have, how can you do it? That is also one idea on which you people can think of to work. Third one is an artificial photosynthesis, because we are facing a more difficulty in pollution issues. We need to grow more trees, but trees cannot be big within a night's time. So is there any system which will have maybe a paint or something? I can paint on the building, which is collecting the light, converting that light and minerals from the ground or something, and generating the oxygen, converting CO2, taking CO2 and converting it to the oxygen. So this is what in a nature-driven process. Why cannot we convert that nature-driven process for an artificial one? So that is also one idea where you can think of to as in a future application or future of technology. So this is all for today's session. And if you have any queries or any questions, you can mail me also, you can call me also, you can ask now also.
Thank you, sir.
Thank you, sir.
Sir, there is one question.
Yeah.
When to go for copyright and when to
Yeah.
go for patent.
Copyright is
differentiate?
nothing. Yeah, we can differentiate this copyright and patent. Copyright means you can write in a book. That is what in a copyright you can get. Patent is an entirely new idea. Copyright may be in a collection of the material, maybe as something innovative, like I can have a music as a copyright, book as a copyright. In book also, most of the time we see all the material is collected in appropriate fashion and it is written. That is what it is a copyright. Patent is in a completely new product and new idea you're going to present it. Any other questions, sir?
Yes, sir. One more question is there. What are the research trends in 3D printing?
Yeah, and 3D printing currently it was developed in different aspects. See, so it was started with liquid to solid conversion. That is what in 1985 that Jacob and people have started that as a rapid prototyping machine. Then liquid to solid, then people have thought it, why cannot we go for sheets? Then it converted into laminated object manufacturing. And then there is a bunch of the different systems people have developed using laminated object manufacturing. Third way comes up in recent way, I can say, that is extrusion. We can take a plastic, then heat it, and pass this through the nozzle with a better accuracy and scan it. That is what a scanning technique you can use it. So in 3D printing nowadays, expected that we are having a single material into it. Why cannot we club multiple materials into this? This is one thing. We cannot go for 3D printing within a metal structures. We can provide in a plastic structures. What is the way we can go for a metal structure? That is also another way you can think of. That is what in a different ways. And 3D printing can also be, if I have a model and I want to have resize it, or maybe my mobile and I want to print this mobile part of it or cover of it, and I want to resize it. That is also possible. You can develop. That is what the way you can think of resizing or modifying your mechatronic system, modifying your electronic system, or you can have an artificial intelligence behind it, and based on that, you can also develop new stuffs. Any other questions, sir?
No, sir.
Yeah.
Okay. Thank you, sir.
So thank you, sir. Thank you very much.
So I will just conclude, sir.
Yeah, you can.
So good afternoon to one and all. So I take this opportunity to extend my sincere thanks to today's speaker of the session, Dr. Suhas Deshmukh, for his knowledgeable and informative session on IPR. We really appreciate your work on IPR and patents filed, sir.
Okay,
I'm confident that the participants would have value addition in the field of IPR, and definitely they will try to patent their models and ideas. Thank you, one and all.
Thank you,
There's
sir.
one
Thank
announcement
you.
for the participants.
Yeah.
Feedback link is being shared on the group, so all are requested to kindly fill the feedback form. Thank you. Thank you very much, sir.
Thank you very much for organizer, Prashant Naravde, sir, entire team of your institute who has given me an opportunity to express my views about patenting and new things. Thank you. Thank you, Naravde, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Yeah,
Yes, sir.
thanks.
Narada, sir.
हाँ बोलो